Well, hello everybody. Welcome to the unprecedented fourth night of streaming here at SkyTour LiveStream. This is a tremendous opportunity because we're actually streaming to a bunch of different platforms right now. We're doing Twitch and Facebook and YouTube together right now, and that's where we're gonna go for now and see what happens. I want to make sure it all works, and if it all works, well, then we're good, you know? So I have with me, of course, Daryl Mason. Hey there, Daryl.
Hello, Mark. Mark, share your screen with me, please.
Ah, you want to see what we're doing?
That would help, I think.
I think you're right. Yeah, okay, let's do that. Okay, there we go.
That's better.
So yeah, in any case, I'm here with Daryl, and we're actually looking at our planetarium program here. Telescope's open and initialized, ready to go, and we're looking up at the night sky in Stellarium here. And the telescope is sitting right there. And if you notice where you see it over here above my head, you see it in there. It's actually in a position where it's literally facing the wall of the observatory. And that basically is kind of interesting. We don't want it facing the wall, but that's just because it's aiming that way for the start. It won't be aiming that way in a short time, but to give you an idea how much that's the view is, if you look at our planetarium thing here, this planetarium show here, I'm going to actually take it and show you the degrees above the horizon everything is right now. So this will tell us exactly how much it is above the horizon. Let's see, there it is. So the telescope's looking at around 11 degrees above the horizon or so. And it's we can see just about 24 degrees above the horizon and up. That's basically the height of the walls. Now, I mentioned the other night that we're going to put the telescope on a lifting pad that actually goes up automatically using a very, very high torque motor and very sensitive motor that goes about a ½ inch per second. So it's going to rise up pretty slowly, but it's going to take the telescope, all 300 pounds of it, up into the air about 10 to 12 inches. And that's going to give us unprecedented view. We're going to actually be able to see trees on the horizon over here. We don't want that, and typically, but you know, it's something that because the sky is so clear there, it's going to be the best thing in the world. It's going to help us to see more things in the sky, even though they're not going to be as good as you might expect them to be. Tonight, if you look up in
down there,
what's that?
you have trees down there.
Well, yeah, there's actually low trees. There's actually mesquite trees and so forth out at the observatory site.
Okay.
We're going to be able to see those. We'll also be able to see saguaro cactus, so it might make for some interesting photos with a silhouette of a cactus in front of, say, Omega Centauri. So that might be pretty cool. But we're you know, we're here to do astronomy, and some creative shots might be fun. Well, here's the moon up there. Okay, you can see the moon, and if we were to look at it, we can't look at it with our telescope because the telescope doesn't like to look at the moon as well. You can see it's just past first quarter, so it's heading toward the waxing gibbous. Waxing means getting bigger, waning gibbous means getting smaller. And we can look at the moon, but right now with the telescope I need to make some adjustments before we can do that again. And once we do, then we'll be able to check out the moon in all of its really, really good looking glory. Right now it doesn't look so hot with the telescope. It's sort of crippled right now, but it will not be crippled for long. So I'm counting down the days and counting down the days. It's only going to be November 5th is when I fly out to Arizona again. I teach in the desert on the 8th, 9th, and 10th, and then on the 11th, I think it is, and Marianne's in the house. She'll be able to tell me. I think it's the 11th that I go out to the desert and I stay there till the. No, that can't be right. I don't know. Well, we'll figure it out. I get 2 or 3 days out in the desert to fix this, so it'll be all right. So I want to say hello to High Speed Low Drags. Yeah, Cypher 2 is here, and Marianne, of course, is here. Daryl, you count too. Hello to you as well. Genghis is here, and I saw that we have Rockstar in the house as well. That's neat. Good to see you. And Raymond Bobel is here, and Carol Carl. You guys are all very wonderful. It's so cool to see you. And I did see Hadley Scott McIntyre was here. I think, is he still here? I hope he's still here. That'd be kind of cool. And Martian Johansson is here. Martian Johansson, how are you? And is here as well. Nice to see you as well. And we're going to be cranking up some altitude here on the telescope to start moving up north, because we're going to be playing around in the north tonight, as far away from the moon as we can get. And then we're going to check it out. It's it's kind of a test night, It's not a night where we're going to be doing a tremendous amount of new things. Maybe we will, but I thought with the moon at first quarter yesterday, we got some gorgeous photos. If you go up to the live server, the live server up there gives you all the photos, and it is just incredible. In fact, I should probably show you the live server just to give you a view of what to do when you go in there. So let me just very quickly take you over to the other side of the world here. Okay, this is the live server view, and when you click the link, okay, this is where you go. You go here, all right, and these directories, okay, are where you're going to go. You're actually going to go to this directory, and this directory gives you every single night that we've photographed anything in the observatory. And let's go to like last night. So we click on that directory just once, and we see that this captured directory has 11 other folders in it, and we open up that and we see the 11. I always label them, so I took the time to label these today. So let's take a look at, say, double cluster. If you go in, you want to see something, you click it once, all right, and what we get when it comes up is you'll see another directory called processed. All right, this is data about the stack of 31 frames. Okay, and this is the raw stack right here. This is the raw data. It's called a FITS file. You do need a special program to read FITS. If you don't want to do that, or if you want to learn how to do it, you can ask me or look it up online. And if you want to then just click on the process directory, then you'll see a beautiful image that was the processed photo from last night. And this, you can simply click download and make it your own and do whatever you like. And that's the process you're going to use for the entire set of directories out here. All right. So basically, like say for the Western Veil, okay, we click on it and you'll see that we have two stacks in here. One with 36 frames of stacked imagery and one with 42. If you were going to be doing the processing, you'd probably want the 42, but you can try the 36. But if you go in the process and you just want pretty pictures, and you click there, and then here is the process shot that we did live as we were taking it. And this image is a nice image, but I'm also processing these further, and after I get them processed further, I put them back up here. So when you come up here, you're going to actually see a second image in here. But instead of having this cryptic name of stack 42 frames 840s with display stretch, it's going to say Western Veil and then all that. Okay, so you'll know which one is which, and the one that you get from me will actually be even cleaner and more pretty than the one you see here. So that is the process, and that is the system that we're using. So now, coming back here, this here is our main screen, and the telescope is currently sitting at around 11 degrees looking up, and we're going to take it up into the sky. We're going to take up ourselves up to the sky, check out a few things. We're going to turn on the view of any objects in the sky, and then we're going to show the constellation lines. And right away, you see over here, you see Altair. Altair is part of Aquila, the eagle. And if we hit the R key with Stellarium, it shows us the mythological representation of Aquila, the eagle. And that is what we're looking at there. And then we move up a little more from Aquila, and you'll see that Aquila is looking at Vulpecula, right? The fox. And then further up from that, we have our favorite star, my favorite star, Alberio, which is a beautiful double star, and Cygnus the Swan. Now we're going to go up to Solder right now, because Solder is a location where there's a nebula there that we have not imaged in probably a week. And Daryl knows the nebula very well. I imaged part of it the other night, but now we're going to look at the main part of the nebula that's here, and I think you'll agree it's really pretty. The only other thing I'm going to do right now is, first of all, let me just do one more adjustment here. All right, and do this, just a minute. There we go. All right. So now I have that blue hue again, and you can also see my fingers better because there's nothing's gonna get cut off now. So what we do is we've selected Solder, that star up there in the constellation of Cygnus the Swan, and we are going to center it up. And I'm going to put my field of view indicator, which is a red indicator, and this is going to tell you that we're going to be right about there when our telescope comes to rest, right? So let's check it out and head there now. Let me just make sure Solder is selected. Okay, and then off we go. And you'll see the telescope move over my head right there. There it goes. It's moving up to the sky. And what I have to do to show you anything that we're doing, I have to just make sure that our camera is set up. I have to attach the camera first. And we're going to attach the camera. The telescope is still dutifully doing its thing. It doesn't need this camera to work. It still knows where it's looking. And we're going to do a 1 second shot here and make it a hyper process shot just so you can see all the details. Okay, and we're also going to make it a more high resolution image, which is raw 16 as opposed to raw 8. Okay, making it raw 16 does cause the image to go away for a couple seconds. All right. Alrighty, so now this, and I have the focus up here too, Daryl, so we can play with the focus as well. Because we want to make sure that our focus is correct. We have three settings that seem to work. I'm going to go to 3 different ones just now to check out how they look. Telescope is still not acclimated to the outside yet. Okay. Like that. Doesn't look quite right. Let's go to this one. And then we can also adjust in between, of course. We have thousands of steps we can go to in here. This gives us an idea. That actually looks pretty good right now. Doesn't it?
Better.
Oh. Well, we'll leave that
found
for
last night that the
592.
92 gave you a little sharper look even than the 50502 did.
Yeah, but that's temperature related too. And if we look at the dome dome, we don't have a dome. And if we look in the building right now, temperature there is 65 now. So that is
Cooling off fast there.
huh?
Cooling off fast there.
Yeah, it's
Yeah.
18.6 Celsius. So 65 is rather pleasant out there. Okay, so that's what we have right now for that, and we're going to leave this at this setting for now. Okay, we're going to leave it at this focus location, which is 50,502. As you can see, we have a lot of focus settings we can go through. Marianne says it's perfect, so we're going to leave it this way. Okay, because she says so. Is that all right? Yeah, it better be.
Sure.
Yeah.
You're captain of the ship.
Yeah, Daryl says the spider's been busy. Yeah, it has been. It's been building the web here. What'd I do? I didn't want to do that. Okay. So, let's go and check out our 1,000 millisecond shot. I want to look here in our planetarium show here, and basically you can see that we're here. We're trying to move. Claims are right about here, which is fine. And I think that that's kind of correct. If I go back to this other thing, center on that, and you'll see that solder should be off to the right a little bit, and it's not. So what I'll do is I will move solder a little bit down. That's a lot of bit. And I'm going to fix that. I'm going to go back, and I don't want to be moving at like such high rates of speed, so I'm going to come back here now a little. We are in Cygnus the Swan, which is the summer Milky Way, by the way. And the stars of summer are rapidly receding from us to the western horizon, where they will remain for quite a while, until next year. As we go around the sun, we will see different stars as the Earth turns to night. We'll be facing a different location in the universe. And that's why we see the stars change during the course of the seasons.
Yeah, if you look over in the southwest after sunset, Venus is going to be passing Antares now in just a couple of days, and Antares and Scorpius are rapidly going bye-bye in the southwest.
That's right. Which is, unfortunately the way of things. But it's alright. Not a big deal. Alright, so this is where solder is. So I'm going to use that as the center. So I'm going to click on solder. And I'm going to say, make that the center. Alright, so now the telescope is aligned to the sky. It's aligned to the planetarium, and everything is in sync. So now whenever we go someplace, it's going to be right there where we want it to be. So here's what we're going to do. We're actually going to go a little bit to the right side here. For now, I'm going to try this. And that means we're going to do this. Now, the sky looks very bright right now, and that's because of the fact that we have our hyper processing on. If I turn it off, you'll see a very different look. You'll also see the halo around the stars. Well, that halo is something that is not right. I'm wondering actually, Daryl, if that's the cluster and that's solder. I have to go look and see if I've done the reverse thing again. Yeah, the which
Inchworm cluster?
Yeah, I've got to see, because see, yeah, that's me. I went the wrong way again because I'm trying to I forget that the scope flipped around. So I have to head the other way. Yeah, the other way. Yeah, the inchworm cluster is not what I want. What I want to do though is I want to put this in the view right here, this dark area, and it's there now, and we should be able to check it out. And let's go a little more over here, and you can see it. You can see the faint nebula there. Okay, but I'm going to show you how this system works so much nicer than what we've been used to out here. Hi Carmen, how are you? Nice to see you. Mr. Spirit is 001. Good to see you as well. And I'm going to come over here.
Satellite.
Yeah, that's right. Let me oh, I think it went out of the picture, correct? Because it was heading north.
Yeah.
Yeah. Okay.
Going really fast.
Yes, sir. It sure was. Okay, so this star right here on the right is Gamma Cygni. It's the star that's the third brightest star in Cygnus, Alpha, Beta, Gamma. They go by the Greek alphabet. And what we're going to do is center this weird looking thing right here in the view. Now what we're going to do is we're going to do a longer exposure, and then we're going to do something called stack it. Those of you that have been here before, you know exactly what that means. It means we're going to take an image like for 20 seconds and then another one for 20 seconds and just keep stacking them on top of each other. And this will improve the noise ratio that we get. I also think it's probably a good idea, now that I just realized it, down here, right, is this setting here. I have to turn on the cooler for the camera. I remembered everything but that. And if you look down here, you can see the temperature of the camera right here is 18.6 Celsius. I want it to be minus 10 Celsius. I want it to be way below zero. So it's already on its way down. The cooler is starting to cool the sensor. And by the time we actually get this situated, I think we're going to be ready. So we can try just taking a picture. And we're going to do a 20-second shot here. And let me just explain what the different settings are. To my right, you actually see the telescope handset. That's telling you what the telescope is telling me. All right. Over my head, of course, is the telescope in the building. And further up, okay, this is the telescope control system here. That's the north, south, east, and west. These are controls that we use to do various things. This is an interface to the telescope computer. Okay, so this is all telescope control. Over here, this is, of course, the main view. Ta-da! It's beautiful, as you'll see. And then over here, this is the camera control system. And if you look here, the most important thing is right here. This is the exposure time. This is how long we're going to have the camera open for. Its sensor is going to be looking for data. Okay, it's 20 seconds. Now, when you're looking to take a picture with a camera, you also have an ISO setting. That's the sensitivity. And you know about 400 ISO film, 100 ISO film, you know, basically 100 speed film, 400 speed film. And the digital cameras go from like 50 all the way to 6400 or 8000 even. Well, this camera goes to several 100,000. And it's not a one-to-one ratio, but it's called gain here. And this gain, we have it set to 350, and 350 is just it's very, very powerful. It puts us well over what would be maybe 400,000 ISO or beyond. And I don't know the exact numbers, but that's because there's no real one-to-one correlation with film cameras. I'm falling. And but that said, that gives you kind of how what we're doing here. This little area over here, this is called the histogram, and this yellow line represents the data being intercepted by the camera. Okay, and if you look here, this yellow line is going through most of the data. If I was actually to move that, okay, if I was moving that, then you'd see that the yellow line is intercepting less of the data, and so the screen gets darker. Okay, this button here gives us a very, very high-end view of everything that's in there, and basically I use it as a finder, a live finder, a live feed finder, and so that's what we've done here. But we're doing 20-second exposures, and we're gonna cut this off and not do this, but then we're gonna do something else. We're gonna go and do a live stack, and this progress bar down here, this green bar filling up, tells us all of the time remaining for the photo. You can see that it's almost there, and when it does get here, it's actually going to overlay this, and you'll see it. Okay, and there it is. That is what's really hidden there. Okay, and I'm going to clear it and do one more because we've been playing around and so forth. So you'll see, and I'm going to set this to auto size so that you'll see the whole thing, and then we can adjust it. So there it is. That's the Gamma Cygni Nebula, and that's one frame right now, and that frame is kind of noisy. You can see it looks a little mottled in here, and that's not right. So as we stack frames, all that noise goes away, or much of it does, and we end up seeing a lot cleaner image. So we're going to do right now is we're going to actually start producing a cleaner image. Look at that. Right now, this is actually more of a realistic color for this nebula right now. I could even take us a little further, okay, and you can see more detail, but I can manually take us up a little higher and make it a little brighter. Okay, so you see the data. And then I can let this stack in the background. It's going to do its thing, man. And we're just going to sit back and watch. Isn't that cool? So this is what's called an H2 region. It's all hydrogen gas that's been so excited by a hot star in the area that it has an electron around the hydrogen atom, and that electron is shot right off the atom. It's called ionization. And now you have just a nucleus, the proton, but the electron's still out there, and it's bouncing around, hitting other things. And as it hits things, it loses energy, and it falls back into probably not the original atom, but another atom. Maybe it is the same atom. And when it falls in, it gives off energy as it falls in. And when it does that, it gives off red light. It's a characteristic light that's given off. Not all the electrons don't fall all to the same place. They fall to many different places, but the predominant one is the one that makes the red light, and that's what we're seeing here. So we're just streaming or stacking these now. I have my nice tall glass of water because I need it when I do all this. As Daryl knows, I don't know when to shut up.
I didn't say anything.
Not tonight. Yeah, so it's pretty cool, and yeah. Okay, so you can see these dark areas in here, these dark patches. Look at the spindly structure here. These are not, as I've mentioned many, many times, these are not voids in the stars and voids in the nebula. It's actually dark material that's in front of the nebula. So that's up here. And the shiny nebula is back here behind it. See? Remember, the universe is 3D. Okay, those things aren't next to each other. Okay, so we know that that's dark dust because we can see it's dark dust. We can detect what it is and so forth. And this dark dust comes from many supernovae that have occurred over the billions of years that the galaxy has been here. These are all in our galaxy. So looking at this, and by the way, this shot, to be able to see a nebula like this, as clear as we're seeing it, and as beautiful as we're seeing it, on a night where there's a moon that is greater than first quarter, like it was yesterday, is a pretty astonishing thing. We're actually using a filter to knock out all that moonlight and show us only this. I think that's pretty cool.
I have a question.
Yes, sir?
Is solder doing the illumination of the red nebulosity?
I think the nebulosity is, was it 1,500 light years away? I think so. And solder's distance is 1,800. No, yeah, 1,800 light years away. The stellarium could be wrong. I usually go to SED or NED or the portal where all the data is curated, so you can actually see exactly what you're looking at. You can see solder in a variety of different studies. That's actually something we could do one night, Daryl. I think people might like to see all that. That's pretty cool.
Mm-hmm.
You know. But anyway, solder is at about the same distance. But solder probably isn't doing the illuminating because solder is an F8 star. That means it's slightly yellow, and it's a whitish yellow. It might be hot enough, but usually hotter stars do that. But the thing is, solder is a giant, a supergiant actually. It's an F8 1b. That, if you look here, you can actually see it. F8 down here, right there. F8 is the spectral class, and this Roman numeral 1 and little b is called the luminosity class. And together they make the spectral type of a star. So the way the stars go are they're hottest and bluest to coolest and reddest. The hot ones are O's and B stars, and then the A stars come next. But then you have the F's. The F's are not particularly hot, but they go from 0 to 9. So this is almost a G-type star, kind of like the sun. So it's only slightly hotter than our sun. However, when it was a normal star. However, when it ran out of hydrogen and swelled up, its outer environment was so far away from the core of the star that it actually got cooler. So the outer edge of the star is cooler than the sun. All right, and that's because it's so big. It's a supergiant star. I don't know the exact size of solder, but it is an F8 1b class, so that means that it's a supergiant of some size. And we're familiar with stars like Betelgeuse, right? Betelgeuse is a supergiant star, a red supergiant. And if you put that where the sun is, its orbit would extend out past Mars. It's just its diameter, its radius, I should say, would extend out past Mars. That's pretty cool. Hey there, Vera Lucia Campos from Brazil. How are you? I'm good, glad to see you. So, when we talk about solder, I don't know how big it is, but I'm not sure it's the one doing the illuminating. It might be a hot cluster nearby, but there's so many stars there, I don't know. I'd have to find out. You can look that up and might probably tell you.
I am looking at it.
Right.
I wonder if Deneb even might be illuminating it. I know Deneb lights up North America and the Pelican.
Yes, it does. And the North America and Pelican are several light years away from the star. They're about the same distance, solder and Deneb. I think Deneb's just a tad closer to us. But this particular nebula, the ultraviolet energy from stars is what causes the nebulae to glow like this. It causes the hydrogen gas to actually glow. And that glow is something that, we'll find it all over the universe, and sometimes it has far-reaching consequences.
Okay, solder is approximately 1,800 light years distant.
That's what we said.
The nebula is 4,900 light years. So, no, they're not physically associated at all.
Correct. That makes sense. Yeah.
Still looking.
No, that's right.
The nebula is illuminated by an O9 class star, which is visually obscured by interstellar material, so we can't see what's lighting it up.
Yeah. And when Daryl says lighting it up, he means ionizing the hydrogen gas and making the gas actually glow and luminesce. So that's,
of course,
that's a very different thing than just, for instance, lighting it up. But it's, you get the idea. He's saying all the right stuff. Of course. So this is a really neat location. And what I want to do is try one other thing here. Let me get rid of one of these coordinate systems and pull in another coordinate system. You'll see different lines appear on the screen. This is the Earth's coordinate system extended into space and superimposed on the sky. And that's what we're doing here. Let's go see what our nebula looks like. Look at that. Wow. This is beautiful. This is 27 stacked images already. More than enough. So what we're going to do is we're going to pause this right here. We're going to pause the stack. We're going to save the stack. Let me just first see what I can do here.
Yep. When you see that image, the nebulosity is not quite 3 times farther away than that star is.
Yep. Yeah. I didn't think that an F8 could, and certainly have the ultraviolet to light this up. It's a star that's already long past its prime for doing that kind of thing. It's a supergiant, but when you see a star that's a 1A, you know, Roman numeral 1 little a, or Roman numeral 1 little b, those are supergiants that have already used up their hydrogen and are bloated. They've already gone beyond their original very productive lifespans, and now they're actually just getting ready to go supernova. This star will be a supernova eventually. So we're going to see a lot of really cool nebulous detail here. I would love to see a nice supernova. I'd love to watch one. And no, our sun can't go supernova. It's just too small. We'd have a few hundreds of millions of years to know our sun was going bad, if it was going bad. And there's no indication yet, so you're safe for now. Very cool.
I know we've debated before about supernovas. You know, it'd be neat to see one, but Betelgeuse, for instance, I'd be sad to see Betelgeuse go away.
Yeah, but we'd be covering the expanding nebulous cloud like you couldn't believe. It'd be such a wonderful, wonderful, wonderful opportunity.
It would certainly change the constellation forever.
Yeah, well, don't forget, 4 million years ago, when, I've told you before, Lucy, the first hominid that became, the precursor to us in Africa, when Lucy looked up at Orion, she wouldn't see Orion like we see it today. Betelgeuse, in fact, would have been a hot O-type star. It would have been a bright blue star in the sky. It would look white to her or us if we were there. It'd be a very bright O-type star. But it would look dimmer to us than the current star, because the O star, even though it's hotter and brighter, it's a lot smaller. And when Betelgeuse became a supergiant, it became far more luminous and visible from a long distance. So Orion wouldn't look the way it did, and there would only be probably, I think, 1 or 2 belt stars in the belt of Orion, because those stars are arguably just around 3 to 4 million years old. So they wouldn't possibly even be there. So Orion wouldn't look like Orion when Lucy was hunkering down, and that was around 4.2 million years ago. So that's pretty interesting stuff. All right, so let's come down here. Now that image I just took will be up on that server site I showed you. And Cypher 2, thank you for putting up that link again. That was very kind. Thank you so much. And then that link that Cypher showed you, and in the description of the actual stream in YouTube, you can actually see that and see the files, because I have a link in there that you can go to. So that's all good. All right, let me come back here again. 1,000 milliseconds. Let's do our hyper view, and that's going to show us this. This is just, like I said, a finder view, so we know where we're looking. All right, now we're going to go just a little bit further to this side here. Hold on. And we're using satellite internet out there for now. We don't have Starlink yet, which will also be satellite internet basically. But we don't have it yet. We're on the list. We're going to have it. And when we get it, we will definitely be able to do what we're doing is more like real time. It's going to be a lot better. So let's go here, and now let's swing over. All right, we're going to swing over because we're going to go to another object that I'd like to show you. In keeping with discussions of supernovae, I think it'd be kind of cool to check this guy out. I think Daryl knows where we're going.
I have a really good idea where you're going.
Yeah. Okay. There it is. So we're going to this little guy right down here. And
well, okay. Not the one I thought it was.
oh, really?
But
that's all right. Where'd you think we were going?
oh, the Veil, of course.
Ah. Yeah, that's true. We could have gone to the Veil. I think that it's better. Might be better. We might be better served to go here, and then we can head to the Veil. I like looking at all the you know the different objects over the course of several nights to see what we're looking at.
Oh yeah.
This
looks like a crescent.
Yeah, this is the Crescent Nebula, and the Crescent is an interesting location because this is a location where this star right here that you see is actually a star called a Wolf-Rayet star. That's wolf, like the animal, and Rayet, R-A-Y-E-T, also known as WR stars. These are exceedingly hot, and they literally have this characteristic where they actually, because stars are made of hydrogen gas, and that hydrogen in the envelope around the whole star makes up, most of the star, but then the actual fusion is going on in the core only, down that little area in the middle, okay? And the area in the middle is where all that is happening, where hydrogen's being made into helium, helium's being made into carbon, etc., as it progresses. And the Wolf-Rayet stars will actually blow off this entire envelope of hydrogen out into the interstellar medium, leaving the shell, the fusing shells of material inside, and that's all that's there. But it doesn't mean that the star is stable. It means it's actually heading toward a supernova event. This star here, right there, is going to be obliterated someday and become a supernova remnant. Let's check it out as we go into our camera controls, and let's go to a 20-second exposure on this, and then turn off our hyper processing and live stack it. And we may gonna have to clear the previous buffer, but not to worry. You can see the green bar is progressing, and the entire shot is going to get read out into the camera from the camera sensor here in a moment. You'll see it. And the first one, there it is. Now this is amazing when you consider this, because we're looking at a very busy region of the Milky Way. Very busy region of the summer Milky Way. Okay, here's other stars. Here's a little piece of the Gamma Cygni Nebula where we just were, and here is that Crescent Nebula, and it's really just a standout item. Let me explain how it works. This Wolf-Rayet star here is in the middle, right? And these stars are very hot, and while they're operating and just doing their hydrogen fusion, and before they blow off their outer layers, they're actually clearing the space all around them. And so it's sort of a very empty space except for the stellar radiation being pumped out, right? Well, once they start blowing off their outer layers, those outer layers go off unimpeded for quite a while until they hit the boundary of that outer layer, of the outer area of the outer clearing where the star is cleared. When they hit that, they rapidly slow down because they're hitting a lot of other material out in the interstellar medium way out here. And yesterday I talked about it, and I likened it to a truck hitting a snowbank. Okay, the truck is this gas moving out from the star, and the snowbank is the interstellar medium stuff that's out here waiting. Okay, the road is clear because the star has cleared the way all the way to the outer boundary of its limits of influence. And then once that stuff hits that boundary, it's just slammed and slammed right down. When the truck hits the snowbank, what ends up happening is the snow heats up and melts. A lot of it melts. Okay, not because of the heat of the engine, but because of the impact force. And that's that frictional activity is exactly the kind of thing that heats up these atoms in this gas. And then the atoms ionize and start to glow, and we see this going on. So this is this star is a hop, skip, and a jump away from exploding into a supernova. And we're looking at it live right now, by the way. So if it were to go tonight, it means that whatever its distance away, it would have already exploded that many years ago, and the light's just getting to us. Because everything we see in this view, every single thing, is like looking back in a time machine. We're seeing it at all different times. For stars that are at the same distance from us, we're seeing them at the same time, but in the past. So the universe is a big time machine. And I just think it's incredible to consider how we actually cannot see the universe for what it is. We can only see it for what it was. And that's really interesting about our perspectives of looking at the universe. But this is a really pretty nebula. It's looking kind of pretty tonight too. I'm gonna see if we can do a little bit of processing to. There we go. Yeah, that's what I wanted to do. Kind of bring it down a notch and just check it out. That's pretty, Daryl.
Yeah. We talked about Wolf-Rayet stars a little late last night, and they're some of the most extreme stars in the universe.
Mm-hmm.
Wolf-Rayet stars could be 1 million times brighter than our sun.
Yep, that's right.
And they're cooking at a furious rate.
They are. The temperature in a Wolf-Rayet star is, many orders of magnitude higher than some of the hottest stars, other than Wolf-Rayets, like some of the O stars. The Wolf-Rayets are even hotter. And I know that when we see planetary nebulae can also sort of look like this. You've heard of maybe the Ring Nebula or the Dumbbell Nebula. We've seen the Dumbbell Nebula. And the Dumbbell Nebula, for instance, looks teal green, bluish green. That's the oxygen, the doubly ionized oxygen glow. So it's not just hydrogen that glows when it gets ionized, but oxygen can too. And when you have ionized oxygen, you get that blue-green glow as well as the hydrogen having the red glow. And the Dumbbell Nebula has both of those things. This nebula right now is mostly hydrogen that we see. It's mostly the red glow. So I think that's kind of funny. Because that tells you it's something different than a planetary nebula. However, there are planetary nebulae that show us that it's not that clear whether it was a Wolf-Rayet star that's active there, or just a star that has died basically and just sloughed off its outer layers, which is what regular planetary nebulae do. This is pretty. And we've stacked 16 of these so far. Also notice just look at the colors of the universe. Look at the colors here. Really the magic color of the universe seems to be this red, this soft red glow. It seems to be the magic color, but there's also a green glow. And we'll see something that looks green in just a second to kind of give you an idea what that looks like. All right. So let's pause this. This will be available up there in a short time. And okay, there it is. The stacked file is now saved up to the server, and it's going to get copied. It's actually saved to the computer in the building, and it's getting shipped up to the cloud right now. And then now the actual photograph that looks just like this is here now. And going to get shipped up there as well, so you'll see that as well. So let's get out of this. Let's clear it first so we don't have to clear next time. And go back. Give ourselves a 1 second exposure. Unfortunately, like I said, because we're using a slow satellite internet out there, it's called Viasat. There's a 1 second delay on everything I do. So, I mean, I operate 1 second behind all the time. I click and I have to hold the mouse to make sure that it takes. Sometimes it doesn't work and it can get crazy and make me nuts. But you know, I'll do my best. I'll do my best. So first of all, just find out to all of you, how are you all tonight? Let me know what's happening. I see weird guys here. Thanks. It's good to see you. And I think I said hi to Martian. I did, yeah. Let's go to one of these other objects I was telling you about. Just back out a little bit. All right, and go down here. Okay, and go here. All right, we're gonna move the telescope, and I have it underway now. So you watch over here, you'll see the telescope move. There it goes. It's not going to move too far because we're not going too far, but it's probably going to use Albireo as its high precision star, and it is. You can see there's an orange star and a blue star there. They're very. I'd have to use a lower exposure here to see it. Let me see if it will actually. I don't think I can get to it before this does this, but let's try it. There they are. You can see the pair now. There they are. Nice. Okay, so it's going to center it and then it's going to whip away to what we're actually, our target is. And our target, you'll see here, when I give you back the view here, you'll see the target here. And here you go. This is now a typical planetary nebula, which is different from that crescent nebula we just saw. This is something else. This is a planetary nebula where the star stopped fusing hydrogen into helium, and when it started fusing other things like helium into carbon, it started to increase in size, and then it would pulsate and then slough off outer layers, and it makes shells around the star, and that's what we see here. I've always loved that color, Daryl. Okay.
Oops, I'm sorry, I was muted.
Right.
Which color, the green or the red?
The greenish blue, yeah, the oxygen 3.
Yeah.
Yeah. It's almost a surreal color, you know?
Mm-hmm.
Look at that. So let me just see if I can. Yeah, there we go. Check it out. We have a satellite going through the field as well. So we do have some anomalies here that we see. And you see it's getting longer. It's going this way. And it might be fading from view. So it might be faint in the next shot here. Or it could be tumbling. Yeah, it's getting fainter. See how it's bright and then faint, faint, faint. That's it's going into the Earth's shadow. But there's the Dumbbell Nebula. That's a really cool thing. Again, this object is one that has been, I guess, the target for amateur astronomers for forever. You know, I don't actually know who discovered this. Do you?
Not offhand, no.
Huh.
I can certainly find out.
I bet you can. I'm doing 5 things at once, so all you have to do is look in Google for me, and I'm sure you can figure it out.
Yeah.
So you look at this structure here. First of all, notice that it's not even. It's not like an even spherical shell. It looks like it has a lot more material up here and down here. Okay, that's probably because it was a rapidly rotating star, and so more material got thrown off at the equators, the equator of the star. and that made it look this odd shape where it had more material going in these two directions. It's probably the rotational axis. Okay, and that gives rise to a bunch of different topologies, in other words, shapes of these planetary nebulae. And so they were called bipolar nebulae, having two lobes basically. A very interesting shape. And so bipolar nebulae are something that are really interesting to see, because how they got that way has always been a mystery. We're not quite sure, but we've done computer models, simulations that actually show bipolar nebulae forming. It's really cool to see.
Mark, what exactly was your question again? Who discovered it?
Yeah.
Charles Messier.
Well, but it was Messier 27, but it's got several catalog names, right?
Apple Core Nebula, Messier 27, NGC 6853.
Yeah.
It was discovered by Charles Messier.
So he was
Who named it the dumbbell? I have no idea.
Yeah, okay. So he was the first, basically. I thought that, we've always known Messier 27, but I wondered if anyone had spotted it before because it was so bright. Did Herschel ever see it? I don't know.
I don't know. Wiki says it was the first planetary nebula, such nebula, to be discovered by Charles Messier in 1764. Okay. So, actually, not a few of the Messier objects are actually seen first by other people.
Yeah.
Or, they wrote Messier and he added them to his list. But Messier found quite a few, and this is one that Messier did find.
Yeah, okay.
He had a dinky little telescope, and
yeah.
Did it show him anything like what we're seeing now? I seriously doubt it.
Well, which is why he thought, he was hunting comets. So the Dumbbell Nebula in his little dinky telescope looked like a comet to him. And he probably observed it more than once so that he could see that it wasn't moving against the night sky, and thus he knew it wasn't a comet. That's, I think, a pretty interesting take on all this. So
yeah, well, stuff like that, he would describe it like cloud, fuzzy, star in the middle, something like that.
Yeah.
Not a comet.
He would observe it again, and then when he would determine it wasn't a comet, he would just call it an object to avoid. Interesting that he would think they were interesting objects, but for him, being a comet hunter, it was just something to avoid.
Well, I think that kind of oversimplifies. Yes, he was writing a list of objects that were not comets, but I'm sure he took a scientific interest in the objects for their own sakes.
Yeah. That's. I believe that's also true.
Yeah.
But his primary interest was commentary, and so I would be interested to have picked his brain to see what he thinks of all these things that he saw. And had he only known that the objects he found were going to be so famous, and I still want to do the Messier Marathon, Daryl. So we have to start that. When do we have to start that? That's in
March,
yeah,
generally.
I was thinking March, yeah. And that'll be once we get the motorized pier that'll actually take us up higher, because then we can actually see more things. We're gonna need to if you want to go see any of the other. There's some Messier objects that we can't see right now in the observatory because they're be impacting the walls.
Excuse me. Yeah. Well, I know Amanda always wanted to do a Messier Marathon.
I invited her, and she, unfortunately, I guess she's got so much going on, she can't do it.
No comment. M27 is the second brightest planetary nebula, the first being the Helix.
Yeah. The Helix is the closest one to us.
Uh-huh.
Okay. Well, that's the dumbbells, so we're gonna leave that one now behind, it'll be up there for you on the server to check out. And then go here and do our thingy. And now from here, I mean, it's interesting that we can see these things with the moon as bright as it is. That's actually kind of cool.
I see comments in chat that I'm really loud. I'll turn it down. Let's try that. Is that better?
It sounds a little softer.
Okay.
Yeah, maybe they're talking about me. Am I really loud? You know what? Let's check this guy out. I haven't ever been here, so it'll be kind of fun to go here. So, I'm going to do that.
Am I still too loud?
We'll wait for them to say.
Let me check.
Okay, let's check this out.
See if that made a difference, folks.
You know, I was playing with my volume settings, and I actually didn't feel like it made any difference. I was trying to get it to make a difference, and it's not. There's a bunch of things that just don't seem to make sense here with this setup, you know.
Yeah.
Not my setup in particular, but just the setup in general.
Martian says I was okay now, I guess.
Okay,
yeah.
no problem.
We'll try that.
Well, it could just be that I'm also low, you know, and I have my volume up pretty high, actually all the way. So,
Okay. I'll move my mic a little farther away too.
All right.
So what are we going for now?
This is NGC, and I think it's 6822, isn't it? 6823. It's a cluster which has some nebulous clouds associated with it, nebulosity. And I think that's the one. So let's give it a shot and see what it looks like. It's a moonlit night, but you know what? It was working pretty well before. Yesterday was a beautiful night. Had some really gorgeous shots. So let's stack this and see. Alright. So the progress bar down there is moving along. By the time it gets to the end, we'll get our first 20-second shot of NGC 6823, a cluster associated with nebulosity. Yes, Cypher. Volumes can be fickle. Oh, look, it sure is. Look at that. What a beautiful nebula surrounding it. See, and that cluster is definitely illuminating that hydrogen. It's causing the hydrogen to glow. It's really pretty. That's nice. Let's wait for a second one so we can then do a little processing on it and pull out some more detail. All right, there's two. Let's see what this gives us now. Oh, look at that. That's really nice.
Mm-hmm.
That's not bad at all. And it moved our black level a little bit, which means that the darks are darker, which is really cool. I think this will give us better color rendering. No, I didn't like that. Okay, so let's go back to this. That's pretty. right. Now, see, the other thing is that we also have the telescope's ability to identify where it is in the sky. And that's actually really important because when he first did this, a telescope's 2,500 miles away from me right now, out in the desert. So if it got lost and didn't know where it was, we'd be out of luck. So we'd have to have, and we do have to have a way for the telescope to know where it's looking at all times, even if we don't know. So we have something called plate solving installed, so that I can just, with the click of a button in here, it'll look at this star field and say, based on this star field, I know what those stars are, and I know exactly where we're looking. And it knows that for the whole sky. It's really quite an elaborate system. I talk about it quite a bit because it really is almost like magic in a way, you know?
Who was it who said a sufficiently advanced technology would be indistinguishable from magic?
That's correct.
Arthur C. Clarke, I believe.
Yeah. And I think that when we talk about extraterrestrial life here, that's one of the prospects that we just can't ignore a possibility of, and that is that if they are here, they are using such advanced technology that it would appear like magic to us, you know?
Mm-hmm.
And I get that. But I get the feeling that you're not like too excited about the prospect that alien life might be visiting us. I think we've talked about that before.
Me?
Yeah.
I'm not losing any sleep over it.
Well, of course not.
I have, I try to think positive. I would have misgivings about such a thing. Historically, here on Earth, when two societies meet for the first time, the technologically inferior one suffers greatly for it, usually vanishes.
Yeah.
It's human nature, I guess. I mean, who knows? I guess we'd have to wait and see how nice the aliens would be. They might be very nice. They might not be nice at all.
Well, my thought would be that we would handle another alien life on another planet in the same way that we've seen in the movies where humans encounter alien life for the first time, and not with bloodthirsty aliens that want to suck out your brains, okay? But if like in this picture right here we've got going, somewhere in this image, okay, I'm sure that there is a planet around one of these stars that has some type of life form, maybe microbial. I will say one thing: it's probably not in here per se. This is a young hot cluster, hasn't been here long enough for planets to form. But out here in the older populations and in these dark nebulae, where there's stuff that has been there for billions of years percolating, it's possible that there are planets around stars in there that are actually giving rise to life and supporting life, right? So I think that an alien life form, if it's become advanced enough to go imply the gulf between the stars, they're going to be smart enough to know that they will have survived by virtue of the fact that they use an approach that's very much hands-off. They wouldn't try to go to war and wouldn't try to take our stuff because they don't need it. They don't need anything our planet has to offer. Nothing. They're not short supply of anything. Carbon is the fourth most abundant element in the universe, and if they're made of carbon like we are, it's everywhere. They can sift it out of asteroids. They could take it out of the dark nebula, with large collectors, right? So they wouldn't need to do anything. The universe would be able to provide them with everything they need. So taking over a planet makes no sense. That I never understood the conquest of a planet, kind of stories. Like Independence Day.
That's always a search for resources thing.
Yeah.
I have seen it posited in some make-believe, universes, whatever, that they would be interested in trade.
Yeah.
if I remember correctly, in Larry Niven's universe, the Molten God's Eye and stuff. If remember the Pearson's Puppeteers, or no, that was Ringworld. The Motis, those weird little critters.
Mm-hmm.
They loved chocolate. They loved hot chocolate. They couldn't stand coffee, but they loved hot chocolate. But then they always put a drop of machine oil in their hot chocolate. And there were other stories that what aliens found really interesting was whale songs, things like that.
Yeah.
Hello, Chantal.
Oh, Chantal's here? Hey, there you are. Hi, Chantal. Nice to see you. Wow. Well, that's pretty, I've always liked those stories because, especially the ones that show more benevolence. I mean, I love the movies like Independence Day, okay, and stuff like that, just because they're a spectacle of visual effects, and I own this visual effects company, right? So it's like, I like those things. I like to see what they did. But honestly, the reality is that it would be much more benevolent than that. I like the concept in Hitchhiker's Guide to the Galaxy. They're going to blow up the Earth to make way for, an interstellar highway?
Yeah.
Funny. Funny, stupid. Douglas Adams was a genius.
The Vorgons, if I remember correctly.
The Vorgons, that's right. That's right. And, I liked, Marvin, the depressed robot, brain the size of a planet. I'm washing floors, or whatever he said. Depends which if you saw the remake of Hitchhiker's Guide to the Galaxy.
No, I don't think I ever did.
Okay.
I read the books, and I remember the one Peter Davidson, the ex-Doctor Who, back in the early 80s, I think, he was in.
That's right. Holy cow, that's right, because they did that movie several times.
Yeah. Yeah. I don't mean to get all philosophical on you, but you asked.
No, I like it.
I think anything we can imagine about alien species, alien cultures, it's going to be colored by human experience.
That's right.
I saw it posited once a long time ago that looking at it from a philosophical, religious point of view, if aliens came here, are aliens in a state of grace, so to speak? Are they without original sin because they're not from Earth?
Right.
You're getting into pretty heavy religious stuff there.
Yeah.
And again, if the aliens were far more advanced than humanity, it could really shatter humanity's culture, their everything. Experiences here on the planet aren't very good for those who are in second place,
Yeah.
And Columbus Day is an example now.
Yeah, right.
Yeah, but who knows? Stephen Hawking, he was one of those who advocated that we should be keeping a very low profile.
Wow, but you know my feeling about that, right?
I've heard it before. You can tell me again.
Okay. Daryl, of course, is correct, naturally, because Stephen Hawking did say, as we all know, that we should keep our head down, like he said. But the fact is, we can't keep our head down. In fact, we have been broadcasting the presence of life on Earth for over 2.5 billion years. And that's because of the buildup of oxygen in our atmosphere. And there are geologic processes that can make oxygen, and there are life processes that make oxygen. Photosynthesis is one of them. And if you are a alien species watching this blue planet from 10,000 light years away, say, you could easily see if we have oxygen in our atmosphere. We're looking to do that technology now, and we're only a few thousand years into our written history, if you think about it, from Sumeria forward. We started writing it down. Before that, it was pictographs and petroglyphs. So, if an alien race is going to do that and look for oxygen, they're going to say there's life there, and they're going to come looking. So I believe that since that was 2.5 billion years of time, let's conservatively say 1 billion years ago, that the populations that were advanced enough already knew about us. Because if they were looking for life like we're looking for life now, we're curious, so we're looking out there. We're looking for planets, number one. Number two, planets like ours. Number three, planets like ours with oxygen. See, we're going down that list. And we're going to find those, you know? And so an alien race, far more advanced than us, will have already done this in a lot of people's estimation, including mine, and would have made their way here once they had the technology to do so. And I found a very interesting parallel, and I did a talk in Denver, Colorado on this. And Daryl, I know you may know about this, so sorry if you've heard it.
Go ahead.
I was researching ancient cultures, Aboriginal cultures in Australia, native tribe cultures in the United States, the indigenous people here, India, cultures there, early cultures in Italy, and other locations on the planet. And I discovered that in almost all these cases, every one of these cultures showed their religious icons, their figures, with halos around their heads. Now, nobody talked to the Aboriginal cultures in Australia 5,000 years ago from Europe. In fact, Europe didn't know Australia existed 5,000 years ago, and vice versa. But the Australian Aboriginals show their deities with halos. Those halos are on their deities called the Wandjina. And the Wandjina were rumored to come from the sky, live under the water, and have full mastery of the water. And so that's just one example there. There are alien pictographs in caves in Valcamonica, Italy, that show warriors with what look like helmets or halos around their heads. Native American pictographs and petroglyphs even show creatures that have these strange helmets. Indigenous tribes in the Amazon show helmeted creatures. Tribes in the deep forests of India show not only creatures that have these helmets or halos, but craft that have beams coming out of them. Okay, now in petroglyph world, an object that has something coming out of it is typically a cloud, and basically you'd see those on the newspaper rocks, the ones that they use to, peck out stories. But these are markedly different, and some of the Indian clouds are very, very different from what look like objects that have these beams coming out of them. So the thing is that the bottom line here is that the halo seems to show up in all of our Renaissance paintings. We see, halo around our deities' heads. Why the halo? Where did that come from? I think that the halo was something observed. It was observed and taken down, marked out, petroglyph, pecked out, painted on a cave wall, passed down through cultural tradition and history. These creatures had these weird halos around their heads. And what would they be? Well, we're already looking right now at what these can be. And there are companies on our planet right now just developing biohazard screens that are electrostatic fields that will be like around your head. Maybe it looks like St. Elmo's fire, a green glow. Okay, but it would protect you from certain things. And it's in its infancy, but it's coming. See? And maybe we're making the halos that we saw, or people saw, thousands of years ago in other places on our planet. So maybe the extraterrestrial presence that visited or is still visiting us had that technology long ago and was using it here to protect themselves because they didn't know what our atmosphere might offer them. They're well aware of pathogens, and so maybe this is a protection from pathogens.
Yeah, or you know, could have just been those clear globular space helmets like, you know, we used to use, I think.
Oh yeah, that's right.
You
It could
know,
be.
how would a tribesman draw a clear globe? You know, he would draw a halo.
And they've never seen, people in that era never saw a glass globe. So it would definitely look like something weird to them.
Yeah. Of course, in religion, or in Christianity at least, I guess halos represented a state of grace.
Yeah.
I did studies for a painting many years ago. It was like mother and child in space,
Okay.
and it was you could imagine a space station, and here's a Madonna-like figure and child, and
Mm-hmm.
they had on space helmets and purposely made them look much like halos.
Mm-hmm.
And I discussed it with a Catholic lady friend at the time, and she was deeply offended by the whole idea of it. That's neither here nor there. But
That's kind of funny, but I mean, I understand. I understand some people's reticence to discuss these matters, but you can't be afraid to face them head on. You can't be afraid to talk about them. And I understand. I understand what's going on. I understand the possibility that it could offend somebody, but if they understand that I'm not doing it to offend them, I'm simply doing it because it's a extremely important it's an extremely important concept to work through, because I could easily discover that everything they think is true. See, it might be that everything they think is also true, and so there is that possibility as well.
I dare say we won't really know until it happens,
I
if and when.
I think
Uh,
I agree with you 100% on that one.
People are hopeful.
Hmm.
People are afraid. People are going to react according to their natures, and we'll just have to see.
That's right.
You know, if they come out with guns blazing, if the aliens do, of course, well, that's going to kind of make up a lot of people's minds in short order.
That's right. I don't think
Uh,
they will. I think that they're going to do what I think they're going to do what we do. When we study a species somewhere in the Amazon or in the Arctic, what do? We take up a long distance view from a distance, right? We watch it from afar, and I think that's what we would do with what we do with animals and so forth. Well, these alien beings that may be visiting us are well aware of the fact that we can hurt them. They're not invincible. The only thing standing between them and us is that their technology, and they know that we're getting more of our technology online every day. More and more better tools. So it's true that whereas we are primitive by their standard, I don't think that we're so primitive that they are invincible. They know we can hurt them, and maybe we have. It's
yeah.
possible we
Well,
have.
I mean, a Native American, an American Indian, pardon the phrase if that offends you, indigenous, whatever you want to call it,
I always say
you
Native
know,
American. It's not a big deal.
he could kill you with a bow and arrow.
That's right.
He could kill you with a sharp stick.
That's right.
Uh, I don't know.
Yeah.
I just, again, I sort of side with Stephen King, though, that I think we should be keeping a low profile.
Yeah.
It, I've heard posited, that it might be sort of like what we would call a robot culture, von Neumann machines, stuff like that.
Oh yeah.
That
The concept of von Neumann.
Terminators, whatever. That
Yeah. That
you
concept.
know,
That von Neumann machine concept, Daryl. That scared the heck out of me as a kid, because
yeah,
I imagined, and it didn't help that I saw this really bad science fiction show where this cubicle robot was going all around the land, chewing up and killing things everywhere it goes. Because that reminded me of a von Neumann machine. Here just to do its job and probe and nothing more. No personality, no remorse, no morals whatsoever. Just a machine doing its job. and whatever gets in its way is eliminated, and it doesn't care. But the von Neumann machine, the idea of the von Neumann machine was that an alien race might send out probes, millions of probes in all directions. And each of them is one of these von Neumann machines that would actually go out and study a culture and report back, or, just go probe, I just thought that the concept was really interesting, but it was also frightening nonetheless.
Mm-hmm.
By the way, we're at the Veil, Western Veil Nebula. This side, Daryl was talking about the Veil. I combined Daryl and Veil. Dale. Daryl was talking about the Veil yesterday. He was suggesting that the Veil is a interesting interesting place, because the Veil will it does remind him actually of a tornado. This part of the Veil does, anyway. As you'll see, we're doing a 20-second exposure right now, and you'll get to see. And if it looks like it's good, then I will get rid of this and let it do its thing. Yeah, there we go. Look at that. The Veil is just an interesting remnant of a star that has blown up, blasted to pieces. A cosmic cataclysm of gargantuan proportions. So, when a star explodes, all of its guts, from the core on out, get obliterated and get sent out in all directions, for the most part. What's left is in the middle is that just the very, very center core, and that can either become one, a neutron star, or two, a black hole. And if it's a neutron star, it could be one of several kinds. It could be a highly magnetic neutron star called a magnetar, okay, which we think might be responsible for fast radio bursts, incidentally, because of the way they operate. That the physics seems to work out so that these magnetars could produce these fast radio bursts, but we don't know for sure. And the other thing it could be is a pulsar, which is just a highly spinning neutron star left behind from the star's demise, with hot spots on it. Hot spots of very high radiation and heat locations that, if they sweep by us, they're like a lighthouse beacon. But just imagine that happening many times per second. There are pulsars. Pulsars are typically about the size of, say, Manhattan Island, okay, diameter of the length of Manhattan Island. That's pretty big. However, these pulsars can rotate very, very fast. The Crab Nebula has a pulsar in it that's going, 33 times per second?
30 times a second, I think.
Yeah, but that's not the fastest pulsar we've ever seen. Just imagine something that the diameter of Manhattan Island rotating 700 plus times per second. It's a real thing. And now, pulsars do spin down over time, but they take a hugely long time to do so. A hugely long time. And you'd say, well, if something the size of Manhattan is spinning 700 times per second, why doesn't it just fly apart? You've been on the merry-go-round or the round little not amusement park, but the playground rides where they spin really fast and you hold on as best you can, but then you fly off, right? Because the pressure, the forces are too strong. Well, a star's the same way. If a star rotates too fast, it can obliterate itself. So why don't these stars, these neutron stars, why don't they do that? These cores left behind, how come they don't do that? The answer, go ahead, Daryl.
No, go ahead.
Well, the answer that we think is that they are so massive and so compact that a teaspoonful, this much, a teaspoon, okay, just a level teaspoon of this stuff on Earth would weigh 1 billion tons. So, and now just, size it up, supersize it to the size of Manhattan Island, and you're talking about a massive, massive star. So it has a tremendous amount of gravity, has a tremendous amount of cohesion, an ability to hold itself together with that much mass, and that's why it doesn't fly apart.
That's why if you took a tablespoon of it away from the star, it would dissociate instantly, and it would make a really nice, huge explosion. Huge explosion.
Yeah, that luckily we don't.
Gravitational forces, nuclear forces holding the star together.
Yeah, that's actually the strongest force. Actually, is the nuclear force. The weakest force in the universe is odd. It's gravity. The gravitational force is actually really weak. Yet you say, well, how come Pluto stays in orbit around the sun so far away? Well, it actually is a tenuous hold. Gravity has a tenuous hold on everything. And it really comes down to understanding how gravity works. And that's a topic for another time, but we will just say it real quick. Gravity isn't like a pulling force. Gravity is a warping, I don't even want to call it a force, but it's it warps,
curvature of space-time.
Yeah, it warps space. And the concept of space-time came from the concept of space and time. Okay, because time dilation also occurs in warp space. So the concept is that, if you had a big rubber sheet and you put a bowling ball in the middle of it, it's going to go right down like this, right? And if you threw a marble down one side, it would end up going around and around and around until it went faster and faster and faster, went into the middle, and then hit the bowling ball. Well, that's the concept of a gravitational well. But that's a faulty construct because that's two-dimensional. Gravity's three-dimensional. It's like there's wells every single place you're looking at, every angle. So it's a simplified, extremely simplified view of what gravity is. And so I think that the whole concept, I'm working actually on an analogy for a better understanding of gravity itself. But there'll be a point where the concept of gravity goes out the window because I saw a lot of papers and read a lot of papers that indicate that what we think gravity is not what we think it is. And that's why it's so hard to get a handle on it. We're coming at it from an entirely wrong angle.
You talk about it not being two-dimensional, of course, that's just a model, and any analogy breaks down eventually. Yeah. In 1996 or 1997, I forget, 96, I think, I attended the Astronomical League's annual convention. They had it here in Colorado up at Copper Mountain Resort. And one day, they had a presentation by some guy. I don't remember who he was. But he talked about gravity and relativity, and he said that the sun was, because of the curvature of space-time in the center of the sun, with the sun's mass, that the sun was actually 800 meters less in diameter than it would be if space-time wasn't curved, causing the gravity.
That actually makes sense. That makes sense. 800 meters with respect to the sun is nothing. Nothing that you could really see with any instrumentation other than the most advanced instrumentation. Because you'd have to figure out what is the border of the sun. We see the sun in the sky, and if you look at it with a telescope with a solar filter, you see this really sharp edge. Okay? But that's...
Photosphere.
Huh? Yeah, the photosphere, right?
Photosphere.
Right. But that's 93 million miles away. And as the closer you got, the less definitive that edge is going to be. It's going to end up looking like a cloud as you get closer to it in a plane. As you get closer to it in a plane, it's nice and sharp, but as you get closer, it just starts to get hazy, and then you're in it, and then you're out of it. It's like, where's the edge of the cloud? Okay, it's the same kind of thing, but at a much higher scale, and much larger. So you'll start to be entering the photosphere thousands and thousands of miles before you think you should be entering the photosphere. And then you'll be in it long before you realize you're in it, and then suddenly you're burned up. So it doesn't matter anymore.
Mark, would you excuse me for a moment, please?
Sure thing.
Thank you.
Now, the reason I told you about the neutron stars and when and what they're left behind after like a supernova is because this is a supernova remnant that we're looking at right here. All right, this guy right here is a supernova remnant. The rest of it is this way. And you can see some of it right here. Okay, snaking down. Okay, but there's another half of it over here. It's actually way out here. It's beyond the edge of this view right here. You can't really see it. But I'll show it to you anyway. All right, this is the Veil Nebula, and this is the western veil. This is the central veil. You can see part of it, and then as we move over, you'll see another large batch of it. This is 28 exposures. We're gonna pause it right here, save this, and then save it all, and then we'll move over and show you the other side, which is really cool. And then we will be able to move to a few other things, let's hope. I do have to check my all sky and make sure that we're still clear. I do think we are. But think about it. This object here is very faint in the sky. It's a 20-second exposure, and look how you see it. All the detail and nuance here. I'm telling you, this observatory is a winner, guys. It's a real winner. You know, I'm so excited about this. We're so excited, actually. Marianne Robb was here before, and she might still be watching from a distance. But Marianne is helping us out there in Arizona. She's very, very dedicated, I would say, to SkyTour LiveStream West. Actually, her license plate on her car is STLSW, so I guess that kind of tells you, you know. Let me just, okay, that's 1,000 millisecond exposure. Let's do that. Because we're going to be heading over to the other side here. All right, and we're going to clear this. This is a beautiful view. And get rid of that. And do our hyper process, as I call it. All right, and that gives us this view. And now we're going to head over to the other side. And that's easy enough to do because the other side is right here. The eastern veil. I believe you're back, Daryl.
I am.
Yeah. And I'm going to head up to the north a little bit. And now I'm going to head to the west a little bit. Maybe the east. Went the wrong way. I keep forgetting the scope flips over when it looks up in the sky higher. Okay, this will work. And then once we get over here, if you come back now and look, you can see this is the eastern veil, and then you can see more of that central veil. This is actually kind of a good spot to stay because we might be able to see a lot more of the veil here this way. Okay, so here's what we'll take it here because you're going to see a lot more over here than you know is there right now, and that's the cool part. I'm showing on the other side of the veil from what we talked about before.
Yes.
And now we'll do this guy.
And there's that profile again.
There's that profile. You can see it. You'll see Alfred Hitchcock. You'll see a whole bunch of other characters, and from your background and what you know about people, you'll recognize people by looking at this. It looks like a profile, as Daryl said the other night, and now that he's said that, I can't not see it.
Yeah, it doesn't really look like Hitchcock. I had to think about this some. I think now it looked like Walter Frey, the old guy from Game of Thrones. Got a sharper nose.
Okay. Okay, that's gotta clear that. That's the old one. All right. Okay. So this is a better view. You can see the central veil there, and then the eastern veil here. Let's see about pulling this in a little brighter. Look at that. This is pretty good for just like I would think from just being able to see from seeing it like this. Well, let me say it this way. This is really good for not having a long exposure. This is only 20 seconds. And you get to see this stuff like right off the bat. I think that's so cool. It's the new approach we're using in the observatories. And this will be for SkyTour LiveStream East as well. We'll have the same setup that will allow us to do that, but it's going to be a magnified view. And out in West, we're hoping to get another telescope out there that's going to allow us to do dual object hunting, where we're going to see wide angle views like this one. This is a 2-degree field. It's 2 degrees across and 1.5 degrees tall. So like 4 full moons across and like 3 moons tall. And we're going to be able to do that. We're going to be able to put another telescope out there that's going to be a fractional size of the full moon in magnification. So it's going to actually be a really nice addition. And we're working on a variety of options for how we'll do that. But we have room for 3 piers in there. Right now there's 1, and we can put 2 more in there. And the telescope that's in there now, which you see over there, okay, right up over my head, that telescope is on a rigid steel pier that I had made out there. Well, Marianne actually oversaw that with Tara Diulis, who helped us oversee all these things. And that steel pier is wonderful. It does its job beautifully. But I want to get the extra visibility, so what we're going to do is we're going to get these telescoping piers, okay, that are able to lift 400 pounds apiece. And one of them can very easily lift the whole telescope up into the air and clear the walls of the observatory by enough to be able to then see everything. And we can't go too high, because obviously, you know, the taller you go, then this gets into play. Things can start doing this. But we'll move the telescope a lot slower. So it'll probably move a lot slower than it does now. And that will allow us to move everything into position. And you know what? I worked in a professional observatory with a 35-foot long refracting telescope. It did not move fast. You know, it did not move fast. And the whole floor moved up and down to meet the telescope. So it was really quite a, you know, quite an eye-opening experience. And so these telescopes, you can't move them fast because they're mounted in a very sensitive way, and you don't want to upset that. You know, we're mounted right now like on almost like a military quality mount. So we could rip around there and it won't hurt anything. But when we get to this other pier, we're gonna have to start taking it easy.
Well, with big telescopes like that, you're talking tons of mass also. So
yeah, that's
it
true.
takes a whole lot more to drive it.
That's right. You're absolutely right. Okay, so let me just take us out of this for a second so you can actually see it full screen. So there's the eastern veil right there, and here's the central veil. Keep in mind, I mentioned earlier that space is 3-dimensional. So this eastern veil is probably a giant shell of material, but on its side to us. Okay, so it'll be on its side. So that curve that you see is probably the curved edge of a very large shell wall. That if you turn it sideways, it would look like that, you know. But when it's sideways like this, it looks just like this thin thing. It's not thin. Some of those filaments are probably much farther than the filaments right next to them because it's a very large distance. Like my pinky looks like it's right next to my thumb, okay? But it's not. It's actually quite a distance away. So in the same way, we're seeing the same perspective effects here because we're looking at 3-dimensional space, don't forget. Always remember that. Hi, Leslie Latin Taylor. How are you? Nice to see you. Thank you for joining us tonight. So this is, like I said, a gorgeous supernova remnant. It really is pretty. We've done 16 of these. That's good for now. We'll just call it there. And we're approaching a waxing gibbous moon, and to be able to see these things like this is really testament to the fact that the filter that we're using on the telescope is really quite good at eliminating extraneous light sources like moonlight.
Suggestion?
Yes, sir.
Check your temperature. I think your focus looks like it's going soft.
I see it, yeah. I terminated this right here because I wanted to go refocus. You're absolutely right. So, we're going to go to a single second. Thank you for picking up on that, Daryl. And now we'll just do this. And let me get out of this. Okay. All right. So let's go and we'll pick one of these objects here. Let's go to 66% on focus, and now we're going to bring up the focusing system. And let's try this 50092 and watch which way the star images go. Let's see if the star image gets smaller. Ready? Go to. Yep, it did.
A little better.
Yeah. Now, I have to explain to you guys, the telescope has a focusing problem that I'm going to fix when I get out there. It's called a collimation error. There's a lens on the end of the telescope with the camera attached to it, and then there's the main mirror of the telescope, and they're supposed to be parallel to each other, but they're actually a little bit like this. They're cocked a little bit to each other. That happened, I think, when the telescope was coming down one day. It actually struck the bottom of its mount and crooked that thing in a way that needs to be corrected. So I have to go do a correction out there, and I shall do that.
What's your temperature out there now?
Yeah, let me see what the temperature is. I bet it's going to be. What do you want to guess? Give it a guess.
50s.
That's like, come on. That's like saying 50s or 60s. If you're a betting man, what would you say?
You were 50s you were 60s when we started tonight, weren't you?
It was 65.
Yeah.
So what do you think it is now?
50s.
You don't want to make a guess about precisely what it might be?
50s.
That's a no. Okay.
I mean, I'm not going to win anything, so I would guess 50s.
Okay.
I mean, it was low 60s here today. It's presently already low 40s, and it may frost overnight tonight.
Okay, well that's just where you are. Okay.
Yeah, but clear skies. I mean, it gets cold in the desert at night.
Yeah, it does. Well, we're at 2,000 foot elevation here, so I'm gonna guess it's 59. That's my guess. All right, let's go see. Oh, okay, it's 61, 62, 61.9. So
interesting that small a change had such an effect on the focus.
Yeah, and it did. But see, knowing this is going to help me because I can program, guys, I can program this focuser to actually refocus itself depending on the temperature. So, for instance, at this temperature, I can get the focus setting, get it perfect, and then tell it to store that. And then do that for a number of focus settings. And then I can actually autofocus this thing too. There's actually an autofocus feature within this program that will allow us to basically focus automatically. But I haven't enacted that. I haven't used it. It needs some calibrating, and there's just too much else to do. Now we're at 50092. I'm going to just go up a little bit and see what happens to the star images. think it went not the right way. Did not. Okay,
Yeah,
so it's going
a
down.
little lower.
Yeah. It might be. This might be the best we can do right now. You think?
Huh.
I know this one is not valid, so we're going to replace this one with 50062. Okay. All right.
I assume those are just steps on a stepper motor.
That is correct.
Yeah. Do you know what that translates to? I guess focus or distance wise.
I do not.
How far are you moving the primary mirror? I assume those are micro steps.
They are.
Yeah.
They're very, very tight. I do not know the distance. I mean, I haven't done the conversion to figure out like what each step corresponds to.
Okay.
Because honestly, I didn't care. I just wanted to know what the range was that was a working range, and then I was going to stay within that range.
Sure. Well, if you like that, let's try that a while.
All right, let's do that. All right, so the next thing now is to minimize this guy. And
Let's show the people something they haven't seen before.
well, we did that yesterday too. All right. But we have new people here too, so that's cool. Let's go back and see what else there is out here. It's a very, very large night sky.
There, it looks like a nice globular cluster there. Don't know how big it is. Excuse me.
Pegasus cluster you talking about? That's 6.3. We saw that. That's M15. We can go look at it if you want. I really can't wait for Auriga to come up. I really want that flaming star nebula like you can't believe. Yeah. So you're talking about this globular? You're talking about that one? You're muted.
Sorry. Yes, Pegasus cluster M15.
Yeah. All right, we can check it out.
I'm trying to read the
Let's go see.
words to see if it gives a diameter. No, I see magnitude.
18 minutes of arc.
18 minutes?
It says, yeah, 18 minutes. It says.
Oh, size. Okay, I see it.
If that's what it is.
That's not going to look very big.
No.
Oh, well.
That's okay. We do have Measure 13 to eventually see. Okay, we're centering up here. And zip off to go to this globular cluster. And where is it, you might say? Well, there, it's right there. But we'd see it better if we just give you a little bit more. There you go.
Oh, that's nice.
Wow, plane just went through.
Yeah.
Yeah.
Maybe a few frames and zoom in a little.
Yeah.
Looks like a nice globular.
Hey, Larry Mason, thanks for coming out. I was looking at Dr. Fox as well. That's very cool. The La Palma volcano, yeah. I always have the La Palma volcano going on in the background because I'm always monitoring it. Because I've worked with the marine people that actually talk about, Simon Day's concept of the breakaway western flank that could cause a mega tsunami. But I think that an awful lot of erosion has to take place for that to actually happen still. This looks pretty resolved there, Daryl. It looks pretty good.
Actually, it does.
Let's go. Let's do a 25-second shot of this. going to be very bright, but we'll do it anyway, and we'll stack it. We'll only do like 5 shots of this or so.
Yeah.
Don't need many, but I'd like to do it. Oops. Beautiful. Beautiful supernova remnant, the veil. Gorgeous. That'll be up on the server. All these photos, remember, go up to our server, and they are there for you to take for free to use for whatever you like. Yeah, there it is. Okay. Actually, it looks pretty nice. These globular clusters, they orbit the galaxy, you know, outside the normal range, as we've talked about before. Daryl's talked about it, I've talked about it. But the globular clusters tend to be tens of thousands of light years away. So you're seeing them tens of thousands of years ago. Pretty cool, you know. And I really think it's pretty neat, you know. Oh, hey, Larry, you said Dr. Fox posted our site on his stream? That's cool. That's very nice of him to do that. I like what he does with the volcanoes. He has good commentary, too. You know, he says things that don't mislead anybody. They're actually quite accurate as far as from what I've heard, you know, having heard it. Cypher 2, thank you so much. He put the OneDrive up there. That link that Cypher 2 just put up for you guys, that's the link to the live data feed. That's the link to the server, I mean. And so that is that's the location, for instance, where all this data will be for you to view and see at your leisure. And just so you know what I'm talking about, that data, for instance, is this screen, this stuff right here. Here's the data. These are file folders, and look, here's up to 2 hours ago, and it's populating data out here. So these are all the directories so far, and the files are being uploaded as we speak. So like, for instance, this one, okay, well, this is one that we did of the Gamma Cygni nebula that we talked about. I told you to be up there shortly. Well, there it is. You know, there it is. It's up already. And there's still more to be uploaded. All right. But again, the stacked frames are these. It says 16-bit 28 frames. It's these guys. All right. They're in the main directory. And then you have the process directory where all the nice pictures are. The raw frames, these are the raw frames that went into making the stack. Okay. I delete these because they just take up server space, and they're just too much. And I don't need them. They're only ping files. I can make them very, very. I can make them space-taking files if I wanted to, and without any loss of data. But I don't do that. So this is where you're going to go. This is it's actually going to point you to this directory, and you go to the end, to the latest. But you can see yesterday's. Okay, we had a whole bunch of things, and if you notice now, I label them. So I'll label them for you too, so you know what they are. All right. So that's what we do, and that is our directory out there, our live server. So it's plugged into the observatory, so every photo gets shipped up there, and by tomorrow they'll all be populated up there. This is looking nice, Daryl. We're gonna just increase the black point here a little bit. And you're on mute again too.
Sorry, yeah, you read my mind.
That's all right. Now let's see if we can. Yeah, there we go. That looks a little better. So yeah, I'm not sure how many stars M15 has in it, but it's always a safe estimate to say between 35,000 and 100,000 for a cluster like this. And you'll always err on the conservative side because there's probably more.
Give me just a second, I'll find out.
And Daryl's going to look it up. Good man. Thank you. I'll have you know, Daryl, that this pier that we're going to install that's going to allow us to go up into the air with the telescope.
Yeah.
I'm doing this for you because you want to see Omega Centauri.
Oh, well, I've seen it. It'd be nice to see it again, of course. And
Yeah, Omega Centauri will be just
hopefully it
giant in
blow
this
your
view.
mind, and blow your audience's mind.
It will.
Uh, it's bigger than the moon in the sky, and it's millions of stars. I forget, 4 million stars, something like that.
Yeah, it's
All,
huge.
all at a ball.
Yeah, that's really huge. It's amazing. And the thing is, and I've told folks this before, these globular clusters are among the oldest in the galaxy, the oldest stars in the galaxy. So, I'm sorry, in the universe. So when they first started, they're mostly hydrogen. They didn't have a lot of other elements in their atmospheres. Stars have all kinds of elements in their atmospheres. Our sun has magnesium, calcium, of course, hydrogen, helium, all right, and a whole host of other elements that are in the periodic table: oxygen, nitrogen, fluorine. Okay, it has a spectrum that we call the Fraunhofer spectrum. It has so many elements in it that, and those don't fuse. Those are just elements that were made in the star when it was formed, and that's like a fingerprint. That tells us what kind of cloud we were formed from, the sun, that is. And so we've spent time looking for our, siblings, and so far we've found one other sibling that was born in the same cloud as we were. And we've since drifted apart, of course, and the galaxy and the gravitational interactions have pulled us around and moved us away from each other. It's like leaving the nest, right? So what that means is that these stars then, like the globular cluster stars, none of the stars in these globular clusters are likely to have planets. The only way they might is if on their way around the galaxy, when they pass through the disk of the galaxy and then come back out, maybe they'll leave stars behind or gain some stars. And the stars that they pull in possibly could be stars that could have planets around them. It might have different chemical compositions, So we see weird stuff like that in the universe, and that's kind of that's kind of par for the course when everything you think you know about your science can be upended with a new discovery tomorrow.
Like to hear about M15?
Yes, please.
It was discovered by Jean-Dominique Maraldi, 1746, but it's in Messier's catalog.
Mm-hmm.
It is one of the oldest known globular clusters, estimated at 12.5 plus or minus 1.3 billion years old.
Okay.
33,600 light years from Earth, 175 light years diameter. One of the most densely packed globular clusters known in the Milky Way. And it has a central density cusp with an enormous number of stars surrounding what may be a central black hole.
Mm-hmm. That's cool. Yep.
Large number of variable stars, a double neutron star system, first planetary nebula discovered within a globular cluster.
Yeah.
Naked eye visibility under good conditions.
Mm-hmm. Yeah, it's like magnitude 6, I think. Kyle Lynch over in Twitch is asking in the chat. He says, would the metallicity affect formation of planets? What that means is when we look at the stars have a what's called a metallicity, and it's the ratio of hydrogen to other elements. And based on the ratio, it tells us how many non-hydrogen, non-helium elements are in the star's atmosphere. And to us, those are metals. And I know that krypton is not a metal, but for purposes of non-hydrogen, non-helium, that's what we talk about. So stars that have the metallicity that are like the sun could have planets around them. Stars that have metallicity like the globular cluster here in this image can't have planets. So thank you, Kyle, Kyle was our first Twitch user for tonight. We are streaming to YouTube, Facebook, and Twitch at the moment. It's a new thing. We're trying to do multi-streams. So we'll see how it works. You know, if we get a following, we get a following. It'd be great. Okay, this is good.
Thank you for indulging me.
No, I think that's great. Thank you for letting us know. I'll save this over. And save exactly as seen. Okay, and now we can clear this and move on. Let's get out of here. Okay. All right, now get back to this.
So it's compact, very bright in the center, may have a black hole in there. Usually don't think about globular clusters with black holes in the middle. That's like galaxies almost.
I know, it's actually kind of strange. We think of galaxies as having supermassive black holes in the middle. Those are SMBHs, supermassive black holes. They're SMBH is what we call them. Go figure. Astronomers love to use acronyms, you know. CMB, cosmic microwave background. Okay, so we're good here. Now we're good here. Boom. Okay. It's such a nice night. Where else do you want to go? Hey there, Tana. Tana's here. Nice to see you, Tana. Genghis, that's funny about Chuck Norris. There's so much going on here. You know we've avoided, Daryl, and I don't know why. We're just going for the nebulae because we can. We haven't gone for any of the neat clusters.
I was just thinking, you got M39 over there.
I know,
right.
I saw it up there, and I think we should go check it out.
Sure.
Yeah.
Where did it go? Is that it there on the right? It's in Cygnus, I know.
Yeah. We can actually show the borders of Cygnus too, so we know. Okay. I just saw it. Actually, let's get out of here and see if I can. It's right here. It's up north of the. There it is.
Oh, okay.
Yeah. Okay.
Sure, why not?
All right. All right, so now we're going to go there, and as we do, we'll actually watch the telescope's view as we go racing across the sky. It's going to take us to what amounts to a high-precision jump-off spot. It's a spot in the sky that it then uses to center up, and then from here we jump off to the object of interest, and it gets it exactly in the same spot as where the star appears. That's its precision finder.
Did it pick Deneb?
I knew you were going to ask me that, and it probably should have. It did.
Yep. Brightest star in the area.
Uh-huh. Yeah, and now it's centering Deneb, and then it's going to take us now to Messier 39 Zoom, which is a little bit north of it. And there it is. Messier 39.
Good cluster, not a great cluster.
Okay.
Bright enough for Messier.
Yeah.
See what it looks like if you want to take a few frames. Take it off hyper.
Yeah, I'm going to take it off the hyper and just try some basic frames here. That's kind of what it looks like in the telescope. If we were to go, say, 5,000 milliseconds or 5 seconds, we'll see the bar move faster across the bottom here, and then we'll see a 5-second photo show up here. Yeah, see, that looks pretty. And we could actually take and brighten it up, pull a little more data, see some more of the fainter stars. Yeah, there's a lot of faint stars in there. You see them all?
Mm-hmm.
Yeah, that's pretty. That's really pretty. All right, let's go to another cluster. I'm not going to save this.
That's fine.
Okay. But we'll just keep this kind of setting for the processing. I know. There's so many clusters. I'm gonna go to what?
I'm sorry. Go ahead.
No, say what you're gonna say.
Have you done the cocoon lately? It's right there.
It is, and it's actually pretty well overhead. Want to try the cocoon again?
Sure.
We'll do the cocoon. The Cocoon Nebula is really fascinating because it's a hydrogen gas cloud that actually is inside of a dark nebula trail, and it's illuminated and causing the hydrogen in one end to glow, and that just looks so cool. So we're probably going to go to Deneb again, for a quick jaunt, and then we'll be back. Unless it's going to find another star nearby. It looks like it's going to go to a different place. What star is it using? The excitement is palpable. It's using a star.
Right, way down there at the
Way
lower
down
right.
there, look at that. By the elephant's trunk. That's alright. It'll be coming back up here.
It should be in Cepheus.
Okay, and you can see you can definitely see this is where the nebula is. The dark nebula. It's a void. It's not a void, it's actually dark dust that's in the way. So if I do this and I give us a little more brightness, now you can see this is that nebular glowing cloud, and then the trail behind it of dark dust. We're gonna check this out. That's cool. Okay, first of all, let's do this. I think I'm still on a 1/4 degree per second motion. I am. I'm going to move over more because I want to actually go farther to the right than we didn't do last time and see what else is out here. It's amazing thinking we can get dark nebula when we actually have a moon out, but we've done it before. Okay, I think that's good, yeah?
Sure.
So let's go over and go to, we'll do 25 seconds. I mean, there's no reason I can't do like 5 minutes, but I'm not going to have you guys sit through 5 minutes each exposure. Just won't do that.
Hi, Isabella.
Isabella's here? Hey. Sorry it's raining over there. Nice to see you, Isabella. Okay. Okay. That'll work. Let's go live stack it. and clear the current one. And then when the sensor is read out with the new data, it'll replace this and we'll have a new view.
Wow.
Yeah.
Well, that's hybrid again.
Yeah, we're gonna fix that.
Still in all, that's pretty.
It's beautiful. That looks pretty, huh? You know, guys, it looks for all the world like a glowing ball that's leaving behind a smoke trail.
Yeah.
You're right, Isabella. Everybody is here. Everybody who's important is here. You're absolutely right. Okay. Just checking out the population. Isn't that pretty?
It is. That's a cool picture.
I wanted to get this edge over here because I knew there's something else in here that was gonna show up. So we'll let this go for a bit. We've stacked 4 frames so far.
Satellite.
Oh yes, there it is. It's probably gonna be here next time. Yeah. And it's fading too, see that?
Yeah.
It's a lot brighter here and now it's fading out.
Right across the
right.
Terminator.
Huh? Yeah.
ISS had a nice pass here some nights ago.
Uh-huh.
Evening pass, and it was almost overhead, really bright. Then it flew right by Jupiter, almost touched.
Wow.
If I had been a few miles to the west, I suspect it would have passed right over Jupiter. Then it dropped off into the southeast, and it winked out. You know, it crossed the Terminator.
Mm-hmm. What's funny is I've attended a lot of UFO conferences, and sometimes they do sky watches. My friend Ben Hansen does a lot of sky watches, and I've attended other people's sky watches, and you rapidly understand those that understand the night sky and those that don't by how they talk about satellites. I had one person saying, the person running a sky watch, and I attended just to sort of listen, and you listen to the torture that I went through. It was said that satellites don't fade out in the night sky. They go horizon to horizon. If they fade out, they're a UFO. That was one thing. Second thing, they don't change color. If they look like they're turning orange and red, then it means they're a UFO. And I was listening to this being said to like 35 people, thinking, these people paid good money to go on a skywatch, and they're being told false information. I went absolutely bonkers. So I very gently raised my hand and said, "Excuse me." And they said, actually, satellites don't go horizon to horizon, typically. And I explained why about the Earth's terminator. And I said, and because of the Earth's terminator, they often do fade out overhead, and they often do change color, because if you think about it, when a satellite is seeing the sun up in orbit, as it goes around the terminator, the sun is setting for it. And what color is the setting sun? Several people said orange, red, Yeah, well, the satellite sees an orange and red sun too, which means that it's being struck by orange and red light. So the satellites change to the orange and red color as well. And this poor person didn't know what to do. I didn't want to be a jerk about it. but she just didn't get it. Just didn't get it.
Oh, I've seen the ISS turn orange as it faded out.
Of course, it was UFO.
I've seen the ISS flare before.
Yeah.
Like, you remember Iridium sats, how they'd do Iridium flares?
Yeah.
Saw the ISS flare like an Iridium once.
Well, that's a good total reflection off the satellite, the solar panels on the satellite, on the ISS. I actually had just hosted a Mars party here, the front lawn out here, and when everybody left, as the last car left the driveway, I was looking down at the ground for whatever reason, and I saw my shadow, and then I saw like a second shadow, and I'm like, what? And I'm watching it move, and I'm like, what the heck? I look up, and there's 2 iridium flares going off over my head, and they're as bright could be. So bright I saw my shadow by each of them. It was incredible. I couldn't believe it. And
Saw a
everybody
double flare.
had just left.
Yeah. They were, they happened about 1 second apart, very close in the sky.
Yeah.
You could see them both before and after the flares. It was really cool. I miss iridium flares.
Yeah. Yeah. I wonder if they do calculate the ISS flares.
I usually use Heavens Above for that, and they don't do that.
Yeah.
They
That's
did cover
like a
iridium
bigger
flares,
show.
of course, but
Yeah.
That's very much an angle of the dangle kind of thing.
Yeah.
You have to be just the right line to see the flare.
Mm-hmm. It really is just the
Right.
glare. It's just a direct reflection off the bright skin of the satellite that's reflecting down
Oh,
onto
yeah.
the Earth. And you just have to figure out if you're in the path of it. And there are people that actually used to chase iridium flares and say,
Yeah.
we got to go 30 miles west so we can catch this flare tonight. And that's like...
I've done that.
You've done that?
Oh, yeah.
Yeah.
Well, I didn't go 30 miles, but yeah, the neighbor and I, one time we hopped in the car and drove a couple miles away, which was to get on the center line of the flare.
Yeah. That's something that I've done here as well. And it's the ultimate...
Well, it just amazes me they could predict it so precisely.
Yeah. Well, that's actually that's actually something very interesting. The iridium flares, and with the with the Starlink satellites, they were trying to make the Starlink satellites not be so bright, so that they could actually not be a pain in the astronomers' butts, right? But they're still a pain in our butts.
Susan Woodcarver asks, have we ever seen a UFO here? Mark or Daryl?
I haven't seen one in our telescope. We see satellites all the time. But I have seen something visually. Actually, 2 things I saw visually that is really difficult for me to put into an understandable framework, is that I actually, when I was in Mesa, I was at Mary Ann's place, because I stay at Mary Ann's house. She's got a big house and all these extra rooms. And last time I was there with the Navajo Rangers, and this time I'll be there with the Navajo Rangers and several other people. It's party central there. There's always a house full of people all the time. And one time, Mary Ann and I were in the backyard, and she says, "What's that?" And I'm looking, and initially I don't see anything. And I look, and just to the right of the rooftops are these 3 objects moving together in the sky that had substantial size. They were actually not small. They were, probably the size of this round thing in the sky, but 3 of them. And I thought, oh, that's just balloons. You know, somebody's having a party and it's a balloon. And they're balloons. And I said, it's coming toward the house. When it gets to the house, it'll probably hit the roof, bounce off the roof of the house. The roof of the house was about 250 feet away, we figured out later. It got to the roof and it went right behind it. I was like, whoa, right behind it. Those are pretty big. The balloons, I calculated the size of the balloons would have to be like 36 inches each. You know, at the distance of the house and the size. And it was actually impossible for that to be the case with 3 balloons, because you would see a number of things happen if they were balloons. There were street lights underneath them, and I thought I was going to see the street lights illuminating them as they went by, because the light was going up into the air. And the street lights didn't even remotely affect these. So that told me they had to be farther away. So that's when Marianne said, let's go chase it. This is the cop in here talking. He's a police officer. And I said, all right, I don't want to take my eye off it, but we'll go see. You couldn't see it unless you were really careful, because it was actually very, very dim, these 3 objects. And so we got in the car and raced out of her development, out into the main road, and got out and blocked the sunlight, or blocked the street lights, and then we just could not find it again. Just didn't know where it went. And I had predicted exactly where it was going with its path. So either it went this way or that way, or did some kind of movement, or it simply landed, fell on the ground. If it was balloons, they had to be massive balloons, and because they would have hit the roof of the house. And that was weird. So that was the first thing I've ever seen. The second thing was when I had the dome here for SkyTour LiveStream. I was preparing the night's viewing for the stream. That's when I used to have to go in the dome a lot. And as I was preparing the dome, I looked out and I saw a star. And I'm like, what is that? What star is that? That doesn't make any sense. That's not Jupiter. That's not a planet. So I confirmed it with charts, and I realized, and in the time it took me to get the charts and look at them, it was still in the sky. And then all of a sudden it was gone. I'm like, wait, whoa, where'd it go? I was looking right at it. And so it was a strange object. Now, you can see a light like that, and if it's sort of brief and quick, that's a meteor coming right at you, you know? Because meteors you see streaking through the atmosphere, but sometimes they come right at you. And when they come right at you, they just look like a bright flash. Whew.
Yeah.
And I thought, well, it couldn't be that, because this thing lasted almost a minute and a half. So I was quite perplexed by this. And I thought, high altitude balloon that's catching the sunlight? Get out the telescope, in fact, and look right at that location. And I couldn't see anything there at all. Not a thing. So that was actually a struggle to try and figure out what it was, and I still don't know what it was. So that's an answer to your question. I haven't seen anything directly. We see lots of satellites though here. How about you, Daryl?
I've seen UFOs several times while observing when I lived up in the high country.
Okay.
One friend was over one night, and I had the telescope out in the driveway up in Leadville, and
Okay.
we saw this very bright red object moving east to west very slowly across the sky to our north.
Uh-huh.
No idea what it was. It was not an airplane. It moved very slowly. We watched it cross the whole Arkansas Valley until it passed the mountains over on the west side of the valley and finally disappeared off in the distance. We must have watched that thing for 15 minutes.
Could have been a Chinese lantern?
Or like a luminary or something. Yeah, I'd wonder if that might be the case. Chinese lanterns or luminaries aren't really a good thing to launch up in the mountains. It's a good way to start a forest fire.
Yeah, they're illegal in some places, actually.
Yeah, it was just a steady, bright red light, and it was ball shaped. It had a little dimension to it. I can't
Mm-hmm.
really say how far away it was. Just slowly drifting from east to west,
Okay.
and prevailing winds are west to east there. Uh,
Yeah.
don't know what it was, but we watched it in 15, 20 minutes until it finally disappeared over the mountains,
Wow.
over on the far side of the valley.
That's
Um, there were others. I don't recall offhand.
yeah. Well, that's still pretty cool.
Closest thing I ever saw, what you might think of as a flying saucer. I wasn't observing. I was driving in the car back to my place from a friend's house over on the far side of town.
Yeah.
We had watched the movie Superman on HBO that night at his place.
Okay.
And heading back to my place, I was facing northeast maybe, and a very bright thing shot across the sky from south toward the north, angled down toward the northeast, and might have been a meteor, but I mean, what I saw, it was three dots. It was a bright white dot in the middle and a smaller, slightly dimmer green dot on either side of it.
Wow.
Evenly spaced, very close together. It didn't look natural. Did I see a flying saucer? I don't know.
Yeah.
I told another friend about that. He said he and some friends were up there in that area, a place called Birdseye Gulch, northeast of Leadville,
Okay.
and they said they saw it land that night. Said it was a flying saucer.
Huh.
I have to take what he said with a grain of salt, though.
Well, it depends what he was drinking.
Or etc.
Yeah.
Yeah.
Yeah. Yeah, we're gonna look at the iris again tonight.
Okay.
Right now, I'm centering up on this to go to the Wizard Nebula, but
Cocoon looked very nice.
it did. It did. So let's see if the Wizard looks equally nice.
You're welcome, Susan.
Yes, you're welcome, Susan. Sorry I didn't respond to that right away. The Wizard Nebula. There's another thing going on in the background that you're not aware of yet, and that is that the telescope has a separate guiding system for guiding exposures, longer exposures. So when I take like say a 2-minute exposure or whatever, the telescope's guiding as well, and it takes 11 seconds for it to get a guide star. So everything I'm doing here, it may seem to take that time, but it is actually good because the telescope is acquiring a guide star in that time anyway. Alright. So let's see what happens here. This is the Wizard Nebula, guys. It's another region, stellar nursery, I should say, where there's hydrogen gas that's been excited by hot young stars. No planets in there that can be habitable, though, because the temperature is a little bit too hot in there. The radiation is too high. Oh, look at that. Wow. That's got some beautiful dark nebula surrounding it, Daryl.
Sorry, I was looking up something for Daisy and Zoe.
Right. Well, hey, Daisy and Zoe. I didn't even see you. I'm so sorry. Cypher 2, good to see you. I know you have to bow out for the evening. Thank you for coming along for the ride. I appreciate your company.
Daisy and Zoe, we can't see the butterfly.
Right.
It's in Scorpius, and Scorpius is set.
Yeah, unfortunately. Sorry about that. But we do take requests, by the way. So if you do know that, then that's if you do want to have something that you know of, please let us know. Don't be afraid to ask. Vera Lucia says, have we thought about putting an infrared camera in there? Well, actually, we have one. Actually, it's right there. This is actually an infrared camera, that's looking at the telescope in the dark. But one thing to keep in mind is that an infrared camera looking at the sky to get like infrared data is a great idea. In fact, it is done from the ground, but only in high mountaintops. Mauna Kea, at the telescopes out there in Mauna Kea in Hawaii, they're at 13,000 feet altitude. That's high enough where they can actually see some of the infrared. See, the atmosphere is very good at stopping the infrared from getting down here. So the infrared signal is best seen from space, from like the James Webb Space Telescope will be, and from very, very high altitude mountaintop detectors. So I thought about it and realized it's probably not going to be able to work. And we can use a low light camera, of course. Effectively, that's what this is. Really low light camera. But we haven't done that. And who's Simi Free? How are you? Nice to see you. What's Simi saying?
I see spider legs again. This must be the same image we were looking at the other night where I saw the spider leg kind of dark lanes.
Oh, down here you mean? Oh, here you mean?
No, in the image.
Okay, I thought you meant the spider that's making the nest here. Or
No.
the web.
The dark object, a little right of center up toward the top.
Oh, this?
Yeah, and then a bunch of dark lanes radiating out from it, and then some farther down.
Yeah, I see those. Yep.
They really jump out.
Yeah.
I'd wondered when we looked at this the time before if I would see them if we looked at it again, and I see them again in the same place.
Mm-hmm.
The dark blob up toward the top, two bright stars to the on the lower left side of it look like eyes of the spider, and then the dark lines radiating away kind of look like legs.
Yeah. I was actually in the middle of an answer I didn't finish. For Simi Free, he asked.
I'm sorry.
No, it's okay. That's fine because I stopped talking because I was trying to read what he or she had said. He said, if you see a bright white light, you might think it's a star, though it's a drone. When you zoom, you'll see a ring of lights. They can be white, green, or red, or a combo. Well, that's true of drones. I actually have a fleet of drones here. I've actually got one up on Facebook Marketplace if somebody wants a large hexacopter. They're used only like 6-7 times. I've got $4,000 into it, and I'm asking $3,150, and it comes with everything but the radio, and it even have a gyroscopic mount for a GoPro underneath, and it comes with the battery too, which itself is like $400. But I know that drones do look like that, Simi. But I mean, here when we're looking at these are obviously stars. So I'm not sure what you're talking about for your view, but I'd be interested in hearing it. Larry Mason asked, what are the dark blobs? Yeah, that's a very good question. These dark blobs that you're seeing are actually dark dust that's between us and the nebula, okay? I'm sorry, us and the stars. So, for instance, they're like here, and the stars are behind them. So they block the stars. Okay, if they were really thick, you wouldn't see the stars through them. If they're thin, you would see the stars through them, like over here. So that's what those black blobs are. They're dark, dusty. Ginga says cosmic dust bunnies. Well, I guess that's kind of true. They are interstellar dust, but the dust is made of a lot of carbon. Material. Carbon, as we've said a few times, is the fourth most abundant element in the universe. So we'll see a lot of carbon atoms and molecules. You know, carbon, two carbons together is pretty common out there. And there's other compounds and other dust. Interstellar dust builds bigger and bigger grains, makes more stuff. And next thing you know, if it forms a clump, that might coalesce and condense into a gravitationally centered sphere of material, and thus potentially, if more and more and more coalesces there, you might end up with a star, or you might end up with a planet. So that's what the dark blobs are. We see those a lot of places we look in the sky, especially at this site out in the desert. We see this a lot. That's a really good question. I want to thank you for that. That was a very good question, Larry. Tana's asking about the Booties Void.
Yes, I'm answering.
Oh, you are?
The Booties Void, Booties, however you say it, that is an intergalactic cluster void. It's huge, but it's extremely far away, and it's not the kind of thing. I mean, you could look right at it and you wouldn't even know it.
Yeah.
You're talking like the empty space between galactic superclusters sort of thing. Way, way far out in space.
Yeah. So there's the wizard, Daryl. Look at that.
I don't see a wizard, but it looks cool.
I don't either. Maybe a wizard's hat?
Maybe. I wondered that.
With some wrinkles in it?
Yeah, okay. Cool. Is that his beard going to the lower right?
I don't know. Maybe. That's a good call. Who knows? Okay, so this... Alright, we're at 20 shots. We're going to pause this and save
Those dark lanes just look so obvious to me.
They are. I mean, they're actually there. They were there last time we were there, too.
I mean, they're so discreet and angular and thin. I guess what makes me think of spider legs.
This here, you mean?
That and those up there. Yes, more there.
Okay.
I wonder at that.
I'm going to... this will be up there to look at later anyway. And now we're going to go and go to the Iris Nebula, which is one of my favorite little nebulae. I love this little nebula. It's going to show very well tonight, I think, in spite of the moon. Oh, I guess I should probably reduce the time here. Okay, that's better. Yep. Yesterday, we were watching these are spider webs that are in front of the camera out there, and we saw the spider crawl up, crawl back down. It's like, hope it's not a black widow. When I was out there last time, I opened up a closet, and I mentioned yesterday there are 6 of them in there. It's like, you got rattlesnakes, you got black widows, Gila monsters. Very different kinds of animals there than here. Here I just have black bears and bobcats. Whoop-de-doo. It seems like every time I go take the dog for a walk, I run into a black bear. It's always, and it's like, the dog looks at me, looks at the bear, and says, "What do I do?" And I'm like, well, go try to make friends, I guess. And it walks over to the bear, and the bear starts taking off like a bat out of hell, and the dog chases the bear and says, "Hey, wait, come on, I just want to play." It's kind of neat, Okay, we're going to move over.
I just posted an image of it's a deep exposure of the Wizard Nebula.
Okay.
I can almost imagine seeing a wizard in that.
All right, so that's good.
Yeah, and he has a peaked hat at the upper left.
Okay.
And I think I see a beard. I almost see his hands too.
Wow.
And there's a little small figure to the right side. It looks almost like a supplicant, like a person, a girl maybe, dark eye,
Okay.
holding her hands up like she's gesturing toward the wizard.
Wow.
I think I picked a bad week to quit sniffing glue. It's a cool picture though.
Neat. I'll check it out. All right, we're gonna go here to the iris. This points out a very interesting set of phenomena in the universe, which I think is cool. I'm gonna dare to do 30 seconds here because I think maybe that I was jipping us out of a better view with only doing 20 last time. So the Iris Nebula is neat because it's actually an interstellar dust cloud, not hydrogen, just dust. And there's a star that is either passing through it or was formed there, and it is causing it's called a reflection nebula. It's blue, and there you see it, and it's actually reflecting off of the dust. Okay, the starlight's reflecting off of the dust and then coming to our eye. And then the rest of the dust cloud you can just start to see here, and it's going to get much clearer. There's another piece over here you'll see. It's going to get much clearer as this moves on. Right, and right now there's only one exposure that we've taken, but when we get two, we'll be able to actually do some better processing like that. Okay. Excuse me. Right, let's see if we can get the color. Yeah, no, I didn't want that. That's wrong. Okay. Let's just do this. Leslie, lions and tigers and bears. Oh my. Yeah. That's it. It's like, well, okay. Marty, we gotta get back to the future. We're just letting this come in here as it is right now. Hey Kyle, what do you mean you transferred? From Twitch? Yeah, I think we'll probably look at Andromeda as well. This object here has so much to offer, and I gotta show you. Now with the moon out, I'm hoping that it won't be too sabotaged. Try taking the black point down. This might be good. Okay, so let's check it out. So this, you can see this object, you can see the starlight in there, you can actually see the reflection nebula in there, and you can start to see this is like brownish dust surrounding this. And it's really, really pretty. Very pretty. I have to, while we're sitting here, I actually have to, I have to do that all sky shot here just to see, make sure that we don't have any clouds coming in. The all sky camera is your best friend when it comes to checking your weather on the fly here. So we're going to our preview. I think I've got, let's see if I got a 20-second shot. We'll find out. 12 seconds. Okay, that should be good. Just got to see if there's clouds. You also see the moon. So now you get to see the whole thing, and I'll tell you what you're looking at. Okay, good. We look good. There's the moon. Got some lens flares across the moon. The Milky Way is here. I'm looking at this and this. I'm seeing that. I'm not sure. The Milky Way is over here. I'm not sure if what we're looking at is clouds or reflective glare. Not sure. Because this is the south down here. This is the north. There is a cloud here. Okay, there's clouds there. There's some light clouds here. So I think that is what we're seeing when we look back at our image here and we see this red. This reddish area. This is clouds. High altitude clouds. It's kind of ruining our shot now. Unfortunately. That's what I thought. That's why I went to look. Let's actually bring this back and see. Yeah, this red is definitely some light clouds that are in the shot here. It normally is not here. But what you can see is this brownish nebula here. Got this brownish one here. It's too bad the shot's ruined. Okay. We're going to come out of here now. I will save it nonetheless. Just to have a historical record of having done so. Okay. I'm actually going to try, for raw frames, I'm going to say save none. Because it's chewing up bandwidth. And I think if I hit save, I'm still going to save my stack or my fits files. And I'm still going to save the PNG files. But I won't be tying up all the bandwidth. Alright, so let's clear this and get out of this, cancel it, and then get out of that. Alright, and let's go to 1 second. Okay, and do this, and I want to try and see. I'm going to do a plate solve. I want to see where we're at, see if it
Not having a problem, are you?
Nope, no problem at all. I just want to do a plate solve. Just do confirmation, make sure everything is good. I mean, I think it is. Okay, so this is fine here. We do have clouds though, Daryl. We got some light clouds. They ruined our iris shot.
Harry Mason asks, "Where are you located?" I assume he means you.
Yeah, I am located in Connecticut right now. Yeah, we got it. Like, let me just copy this. I'm located in Connecticut right now, but the observatory is out in the Arizona desert. It's about 2,500 miles away. Okay. The telescope is saying it's pointed at 20 hours, 56 minutes, 13 seconds. And 20 hours, 58 minutes, so 3 seconds is where the center of this field is. So that's actually pretty close. And it's 57.55 north. 67.55 north. And we're pretty close on that. So that's not bad. I was just checking the accuracy over time. It seems like we're doing fine. Okay, we're doing 1 second exposures here. And we're hyper processed. And I'm going to come out now. Let's go see what else we can view.
Suggestion?
Yep.
Remember we looked at LDN 1251 the other night? You want to try that?
Yes, we did. Let's go find it. And then we'll tell you all what that is. It's called Lynn's Dark Nebula. I wonder if it's known as Lynn's. No. Oh, it's 1 second delay is killing me. No, okay. LDN?
Yeah. 1251.
Yeah. Okay. We're very close to it. So let's go there, shall we?
Sure.
Yeah.
I seem to remember that looked cool the other night.
It did. And that was on a moonless night, but let's see what we get. What are we going to use for a star? Ah, that's what we're going to use. The star we're using is this one right here. Oh, I can't do it because the scope's there. Alright, well it's going to go to... It's going to go there. So it's going to put that star in the center. And once it centers, it'll then move to our object that it knows where it is. Okay. There's definitely an object here. Can't miss it. There's something here. Something hiding. Shall we look?
There's nothing there. Sure, go for it.
Okay. Wow. Delay's up to about 2 seconds now. Okay, now our live stack. Let's make sure that we're good. We are. This is another one of those nebulae that's called a dark nebula. And it's composed of that black dust we talked about. It's actually brownish gray dust. and that's actually known as Lynn's Dark Nebula. And E. Barnard is a guy that, oh, duh. How about that? Apparently I didn't clear it. E. Barnard is a guy that actually cataloged a lot of dark nebula. And there's a catalog online of Barnard's dark nebula that you can actually reference and look at all the different dark nebula. And of course, then we go look for them here, and they're really cool. What's going on? Why am I... Is this Lynn's Nebula? Oh yes, it's a star. You know what I thought? For some reason, I thought it was stuck in a cocoon. But it is Lynn's Nebula. You can see it there. See how noisy it looks? I say this a lot. It looks kind of noisy and blotchy. And you notice we stacked the second one, and it's even looking better already. And it's because the more data we get, the more the noise gets averaged out.
Seems like it looked cooler the other night. You say you're getting some high clouds?
Yeah. Well, actually, let me now that we have two, let me do this. Yeah. See, we definitely have high clouds right now. Because by doing this, you wouldn't see it like this. We're missing out on a whole bunch of data.
Yeah.
Well, we're hanging around in the north. That's where the clouds are. It looked better the other night.
Yeah. Oh well.
That's okay. Let me see while it's stacking, doing some things. I mean, we're actually getting near the pole anyway. We did the iris. I mean, what about the swimming alligator cluster?
Go for it.
You know, it's actually not a very populated cluster. It only has like 50 stars.
Also known as the Bruce Lee cluster.
Come on, where'd those names come from?
Well, I think those are more stellarium names.
Can those people do that?
They can do whatever they want.
Yes.
What they've been smoking.
Mhm.
I thought I was bad.
Nah, you're not bad.
Picked a bad week to quit sniffing glue.
Airplane was a funny movie.
Yeah.
Looks like I picked a bad week to quit amphetamines or whatever he said.
Yeah. Lloyd Bridges.
Huh? Yeah. 7822 we did the other night. I actually want to come back up here and get out of the clouds. I want to do this right here. So we're going to check that out shortly. Let's check this out now, though. Oh, yeah. This is definitely not what we expected. Okay, I'm not even going to save this one, guys. Sorry. It's terrible. We should be seeing a lot of detail on that right now that's not there. So, what we'll do is come out of here and go to 1 second again. And go to that. All right, and now let's see if we can pull ourselves out of the clouds here. Okay, go for it. Okay, we're coming back. a little bit out of the clouds, I would hope. Let's see what star it's using as a guide star here. Okay. It's using the star that's right there. I'm trying to see the name of the star. It's Zeta Cephei, I think. And then we go off to this cluster we were trying to see here. Okay, now that's a star cluster. That's a pretty cluster. See all these. Very, very pretty.
Ark, excuse me a moment, please.
Sure thing. All right. Let's go. What's this one here?
Saw you go by the Garnet Star down there a second ago.
Did I?
Yeah. Just went out of frame down at the lower left. Anyway, excuse me.
Okay. Yes, that's right. The Garnet Star. I know what that is. That's a fun one to look at. Yeah, that's right. It's part of the elephant's trunk. Okay. Arrakis. So we're just poking around here. We were looking at this nebula, not nebula, but the star cluster here, right there. They're kind of cute. So I like looking at sometimes look at those things. But I might want to look at one other thing right now that is just a bit more exciting. So let's do that. We're going to look at the Andromeda Galaxy by requested by Kyle Lynch, Lynch Hub in the chat. Let's head there now. So off we go. And the Andromeda Galaxy will be relatively high in the sky tonight at this time. Let's see which star we're centering up on. Mirage, as before, yep. Isabella, I navigate from Stellarium at times. I can also navigate from this program up there. This one here. I do notice a difference in coordinate system between here and here. There's a little difference. Sometimes that causes issues. For the most part, we're okay. And for the most part, that's the Andromeda Galaxy. So we're going to check it out, and this is always a big finisher for any night, I can tell you that. It's 10:10 out in the desert, 1:10 here in Connecticut. Okay, we'll do that. And now, let's go do a 30-second exposure here. We've moved to the Andromeda Galaxy.
I see that.
It'd be nice to check it out on a night like tonight with the moonlight. Alright. And I got it favored to the upper side because I want to see the extent down here. So let's go. We're 30 seconds right now. Yep. And so we'll take it off of here and go into our live stacking. Live stacking. That's just what we are doing, live stacking. And we'll clear this. That was disappointing tonight with the clouds out north. We'll find out if there's any here.
Well, I took a quick trip outside. It's starting to cloud up here too.
Okay.
Moon was pretty. Getting close to setting over the mountains and
Yep.
Down below Jupiter and Saturn, which are also getting ready to set.
There you go, guys. What do you think of that, huh? It's a little red. I gotta change the colors. And that's only one frame so far, but we can still work on it. I'm going to check the all sky again, because normally I can change the colors a little better, a little easier. Let's see. We're kind of looking over here. So let's see if there's something there now. I see some clouds here. There's some clouds there. We have a few clouds. It doesn't look bad. All right. This galaxy is 2 million light years from us, and it's actually on a collision course with us. But it doesn't matter. It's not going to hurt us. It's going to pass through us like we're not even there. That's a promise. But it's going to rip our galaxy into pieces and make it a whole different type of galaxy at the same time. But don't worry. It's not going to be something that's going to hurt us. The stars are so far apart from each other that they'll just pass through as if it's not even there. But the gravity, the mutual gravity of 1 trillion stars of that galaxy versus 150 billion or 200 billion like our galaxy will mean that we're small fry. We're going to be absorbed and eaten by that galaxy. A couple billion years from now, though. You don't have to worry. Don't worry. Don't pack yet. These dark lanes in here, these dark things, this is dark dust just like we see in our galaxy. You know?
They're like the Great Rift we see in the Milky Way.
That's right. The Great Rift being that dark black line you see that moves down through the Milky Way. It kind of looks sort of like in its center. You'll notice this little area. Let me actually make this a little bigger for you. Okay. See this area here and this area here? These are all hot young stars right here and here. See that area is kind of brighter. Those are O and B stars that are very bright. We have some at the other end here, but I'm focusing on this end tonight. This M110 here.
Yes.
Okay, and then this is Messier 32 down here. These are companion elliptical galaxies to Messier 31, the Andromeda galaxy. It's a little bit too red. There's actually, if we want to get this right, the background shouldn't be as blue, and we shouldn't have a red center on this galaxy. It should literally be more of a yellow. By taking out some of the blue, it actually helps it approximate what it's supposed to be.
For all you're catching there, we're still not seeing all of it.
Correct, yeah.
Andromeda is about, if I remember right, it's like 6 full moons across.
Yeah, it's 3 degrees or more. Could be probably 4 degrees across the sky overall. Yep. But that's what we get, man.
Isabella asked, wouldn't it cause starbursts? Is that sort of what's going on there at the lower right part? That big association you mentioned?
Here? Well, actually, yeah. I don't know if you'd call it a starburst, but you know, she's right. M82 is a starburst galaxy.
Yes.
And M81 and M82 actually have a long history together. Their interaction together, and we'll see M81 and M82 soon, and soon enough. And they look beautiful in this telescope. And from there, from Arizona, I can't imagine how beautiful it's going to look. It's going to be stunning. The starburst galaxy M82 is undergoing starburst primarily, potentially, because of an interaction with M81. So I think that's where Isabella's coming from, saying, could that cause starburst in our galaxy? And starburst means stars don't burst. It means a star formation, rapid star formation. So it's possible that when the Andromeda galaxy, M31, comes through our galaxy, the proximity of all that mass to our mass could cause a rapid onset of starburst star formation. That's very possible. Along the collision lines, there might be all this material mingling that could lead to a starburst formation of starburst formation. So that's a possibility.
Where your pointer is,
yeah.
I mean, there is star formation going on there. It's just not as hectic as like a starburst galaxy.
Correct. You know, this is sort of normal spiral arm, star formation, because it's in the spiral arms where stars form. That's why the spiral arms are bluer than the core of the galaxy, which is yellower. Okay, so that's actually what the difference is. When you look at a spiral galaxy like this, you see that, And I really think it now. I feel that I was going to make this the last object, but now what I'm going to do is I'm going to pause this. Again, I'm not going to save this one because we do have high clouds, but I'm going to take us now to the other guy that we like to look at.
M34.
Exactly not.
M33.
Yeah, I know you knew that. You were kidding with me. M40,
Yeah,
M44.
you mentioned M82. I know Starburst Galaxy. That's also that's the same thing as the Seyfert Galaxy.
I'm not sure what I'm not sure of the Seyfert Galaxy definition relative to like a Starburst Galaxy. So
I'd have to look that up.
that's the
But I know, like, well, Carol asked a minute ago. She said she doesn't know what a starburst is. Um, uh, if that star forming region we just looked at in M31 is like a stellar nursery, you might say that's like a firecracker going off, whereas M82 might be like a whole handful, a whole string of firecrackers going off at the same time.
Yeah, it's like a stick of dynamite compared to firecrackers.
There you go.
Yeah.
Stupid analogy, but
no, actually no, but that's good because it basically shows that when stars form, these shock waves that went through the galaxy form compression fronts of material, and that heated stuff up, just like we see at the edges of these cavities with supernovas, right? They expand, and when the progenitor star, the original star, has cleared this cavity, when that material leaving the supernova reaches the edge of that cavity, it compresses and gets slammed down, slammed to a halt, and heats up dramatically, ionizing that gas. So, that's okay. I mean, these shock waves do things in interstellar space, including form stars by the millions.
Yeah.
So that's really
okay. It seems like, if I remember correctly, back in the day of film, I'd look at images of M82, and I don't remember seeing the red emanating from the center of the galaxy like you do in digital images now.
Yeah.
I wonder if that's just something, that digital seems to be catching better, or maybe I'm just misremembering.
I just think that the sensitivity of the cameras has changed, the sensors and their ability to see the spectrum well balanced has changed. But it's possible that there could have been a short-term change in the galaxy, but I seriously doubt it. At those scales, things change very slowly.
Oh, well, I agree there, certainly. I don't think anything would have changed physically in the galaxy in such a short time. Our technology has changed, I guess.
Yeah, that's for sure. Okay, this is Measure 33 now that Daryl likes to call Measure 34, even though he knows it's Measure 33. He's kidding around. Alright, so let's go and we'll do 25 seconds here. Okay, the Andromeda Galaxy we just saw is a galaxy that is a spiral. You can see that the spiral arms are a little more tightly wound here. Okay, and in this next galaxy, the spiral arms are not as tightly wound, and it's known as an SC galaxy. That is a spiral with less wound arms, so that the little letter C, so capital S, little c. Andromeda is a capital S, little b. Okay, and here is the this beautiful galaxy, and you can see the spiral arms. Yeah, this looks nothing like the other night. We have a lot of high clouds now, but you can see the red areas in here. These red areas in this galaxy represent the equivalent of, say, Orion nebulas and larger nebulas. in this galaxy. And the tiniest little white dots you see in this galaxy are globular clusters. And they're all cataloged, believe it or not. Every one of them.
Well, that picture I sent you, you looked at this morning, I think.
Yeah.
What there are 21. He showed, I think, 21 objects, and they were all NGC objects
Mm-hmm.
in another galaxy. Usually, the whole galaxy might be called an NGC object, but there's so much going on there. There were like 20 different ones inside just one galaxy.
Well, these galaxies, Andromeda and this one, are relatively close to us, so we have those kind of labels for these particular galaxies. Not bad, though, huh?
I've said before, summer of 1980.
Yeah.
I was living up in the mountains and was out on one really dark summer night up there, and I mean, Andromeda was very obvious to the naked eye, and I thought I saw M33 naked eye.
Wow.
Little dim patch over to the side of M31. You couldn't miss Andromeda naked eye.
Yeah.
I haven't seen a sky like that in a long time.
You haven't been to Arizona.
Yeah. I need to get out of town. Is what I need to do.
You need to get out of your town, yeah, because it's very brightly lit.
Ah, well.
We need to move to Arizona.
Too hot.
Mm-hmm. Go to Portal down southeast. Higher altitude, probably 10 or 15 degrees cooler than Phoenix. It's hot
Really?
in the desert, but I'm at 2,000 foot elevation. It's still hot.
Well, we wouldn't be much different here than it is there if it weren't for the altitude here.
Mm.
That's one saving grace of this place is
The altitude?
it stays relatively cool here because of the altitude.
Yeah, but you get relatively winter there.
Yeah, but I mean, I grew up in southern Missouri, and winter was worse there than it is here.
Probably
It's a different story. It's a different story if you're up in the mountains here. I mean, you know, God, they get 400 inches of snow a winter in places up there.
They get 400 inches of snow a week.
Winters are actually pretty mild here in the spring.
Oh.
We can get extreme weather. I mean, October 15th, 1984, it snowed 3 feet here in Colorado Springs overnight, and 4 feet out south of town. That's a pretty rare thing, though.
Yeah.
If it does snow here, it usually melts the next day.
Yeah.
The sun comes back. It does that a lot here.
I want to say hi to Emerther Aliens. Hi there. Welcome to SkyTour LiveStream. If you haven't been here before, this is our wonderful remote observatory out in the Arizona desert that we're operating from the East Coast. And this is the Triangulum Galaxy that we're looking at right now. You can see this beautiful core of the galaxy with all these beautiful dark tendrils of dust. You can see these red hydrogen 2 regions. These are star forming regions like we have in our galaxy. You can see supernova remnants like this one, that one, and where's the other one? You got 1, 2, 3. There's another one. I missed it. Where'd it go?
Way down at the bottom?
Is it way down the bottom? Yeah, there it is. Sorry, thank you.
Down right there.
Yeah, I had zoomed in and I screwed myself up. And this is an SC, more of a sloppy spiral galaxy. You see the arms are not really cohesive and tight. They're kind of loose, and that's what we call a SC, capital S, little c. We have SA for very, very tightly wound spirals. We have SB, like the Andromeda Galaxy, and SC. So they're all all over the place. That's a really pretty galaxy.
M33 close enough to M31 they could have gravitationally interacted?
Maybe it depends on their speed, their direction through space. I never did any research on these galaxies to know. Just like
33 is so much looser than 31.
Yeah. But I mean, it kind of reminds me of the fireworks galaxy, which is also loose, and I don't know that it ever really interacted with anything.
Yeah.
Let's see here. Let me try a little enhancement here, because I am doing an unsharp mask on this now. Let me change the radius here a little bit. Let's see, I just watched the image here. Okay, it got a little bit sharper, see that?
I'm sorry, I was away from them. Let me go back.
That's right. I said I increased the size of the radius for the unsharp mask, and we can actually see more detail now. Here's another H2 region. Little one there, big one there.
Yeah, that's 604 right there.
Yeah. So there's a lot of these here. And there's another supernova remnant right there. There's one right there. There we already talked about. There we already talked about. Down there we already talked about. And just incredible. There's a lot of these regions. And the arms of the galaxy are still star-forming regions. Larry Mason, we stream most clear nights, but this week's been a little bit nutty. We streamed 4 nights in a row, and I don't usually do that because I do need time to recover. But you know what? The Arizona sky it just doesn't stop infecting me, and I have to open up again. And I figure if I'm gonna do it, I'm gonna bring everybody with me. Why not? Because everybody has cool things to say. They have requests. They want to see things. I have no trouble with that. I just love your company. You guys are great.
Wiki says M33 is believed to be a satellite of the Andromeda Galaxy, or on its rebound into the latter due to their interactions, velocities, and proximity.
Yeah, they're actually very close to each other in space as well. I think this is like 2.4 million light years away, and Andromeda is 2.1, something like that. And they're actually close to each other in space. So they are each other's biggest galaxy they see from each other. So I think the Milky Way would take a little bit of a second place to this galaxy as seen from Andromeda. Oh yeah, the Needle Galaxy is beautiful, but we can't see that right now.
Needle Galaxy.
Yeah, that was.
I'm sorry, I'm still on the other page.
Rascally Rabbit was asking, and by the way, hi Rascally Rabbit. He was asking about the Needle Galaxy.
Oh yeah, NGC 4565.
Yeah, one of our favorites.
Nice.
Yeah, one of our favorites.
Uh-huh.
Well, very nice to have you here, Rascally. Thanks. This is our last object for tonight, Rascally. This is the Triangulum Galaxy. You might notice this red haze around it. That's unfortunately there's high clouds, but I'm very pleased to see that those high clouds have not actually done too much damage to the image. Doesn't actually look that bad. So here's what it looks like, and you can see this kind of whitish glow. That's indicative of clouds, and the scattering done by the clouds passing in front of the galaxy makes it sort of a white glow. But no worries, I can actually get rid of that. I do what's called a synthetic flat field on it. So there. Do that, Isabella. Synthetic flat field. Okay.
Boy, the wiki has a close-up of 604.
Yeah, it's got a lot of tendrils in it.
Yes, it's really something.
Yeah. We can't see those with this. I bet you if if we did a really short exposure, which didn't care about anything else, we might be able to see some detail there. But it would be very, very limited.
I'll post a link to this.
What's that?
I will post a link.
Okay. Thank you. Wow. Well, there we go. Well, folks, that's the Messier 33 Galaxy and Triangulum. I hope you enjoyed our foray into the universe tonight. This is our last object for the evening. There are so many more to do, yes, I know, but we can't get to everything tonight. And I actually have to get to sleep, and it's like this is so taunting me, because there's some things in Auriga that I really want to see, and Auriga's over here. Okay, there is Auriga right there, and I really want to see a few things in here, namely the Flaming Star Nebula. I'm dying to see that. And when Orion comes up, well, and Monoceros, well, we're going to see a bunch of really cool things. Right now, M82 is right here. It's M81. M82 is right next to it. And it's literally only 11 degrees above the horizon, 12 degrees above the horizon. We can't see it from here. The telescope would be pointing into this area to kind of see it. If we had the telescope on a elevating pier, however, we could actually go see it. So that's another reason we're going to do that. So all that said, I am going to close down for the night. I want to thank you guys for coming out. We will, in fact, do this again very soon. We stream most clear nights. Look for the notifications in Facebook. Oh, Leslie, thank you, hon. Thank you so much. That's so kind. Look for the notifications in Facebook and Twitch. We're streaming to Twitch, Facebook, and YouTube. So look for all the notifications in those platforms for when we're going to stream again. And if you go to windy.com and look out in Arizona and select the clouds, you can actually see if it's going to be clear. And we're located south of Wickenburg, Arizona. So we're 65 miles west of Phoenix, out in the desert. You got to drive on many miles of dirt roads to get to where the observatory is. And it's on protected lands. And there's literally no less than 27 security cameras looking at all various aspects of the property, and they're extremely high-end cameras that the scientist who owns the land had put on there. And the observatory is off the grid entirely. It uses solar power, and we actually, when I stay out there, you actually have to cool your water when the water comes out of the ground. It's a well, because the water exits the ground at like 98 degrees. So for taking a shower out there, you don't have to heat the water. You have to cool the water. Really kind of cool. Neato.
No,
So I
thank you.
want to thank you guys for coming out here. And if you want to go exploring, feel free to go to our live server location that you have the link for. It's a static link in Facebook under my name, Mark D'Antonio, or under SkyTour LiveStream with Mark D'Antonio. That Facebook page or group, you'll see pinned links at the top, and it goes to a OneDrive server. That's a OneDrive server that's actually available that we've been using. And so all the photos we've just taken right here, as we've been taking these photos, I think I stopped this one, didn't I? Yeah, I did. We took 26 of those. Those 26 frames are stacked and put out on the server. So if we just go to that server really fast again, let me just take you over there. Here is the server screen. This is our server location, and these are our things right here. 5 minutes ago we've already had things going out here, and if we look in processed, okay, already look what we have. This beautiful Messier 33 Galaxy is already here. It's already sitting here waiting for you, so you can enjoy it now and take the photo and go enjoy it. So this link is given in our Facebook profiles for SkyTour LiveStream and me. So check it out. Go visit, take them, enjoy them. If you want to process things yourself, then when you go into the folders, you're going to end up going to, like, this is the main folder. So you can go look in August. You can look at the August things that we took pictures of. Okay, the Cat's Paw Nebula, the lobster. Okay. You can go to any of our previous streams, and when you get in there, you'll see that they're labeled. Okay, so when you come in, you'll see the names given. I've taken the time to name and tell you what everything is, but you have to go through the first directories first. And then when you go in here, these aren't labeled yet because I didn't get to them yet. But I will eventually. What's that? Daryl, did you say something?
I don't think so.
Okay. So anyway, there you go. That said, I hope that you guys can enjoy these things and enjoy the beautiful imagery. I make every effort to make sure they're available to you. I used to publish them in Facebook on the Facebook site and SkyTour LiveStream site, but not everybody has Facebook, including, guess who? Daryl. So for him to see him, he has to go someplace else, or I have to give them to him in Skype. I can still do that for him, but I think that it's important to have them accessible to a lot more people. So
say goodnight, Gracie.
Good night, Gracie. Yeah.
All right.
So I'm going to
Have
shut
a good
down.
night, everybody.
I'm going to shut down here, and if you want to watch me do the shutdown, you can.
I'm going to go.
What's that? Okay, so
Take care. Good night, everybody. Thanks for having me on, Mark.
oh, okay, you're heading out.
Yeah.
Okay. All right, Daryl. Thanks.
All right.
Man. Talk to you later.
Bye-bye.
Bye. Okay, so now what we can do is I'm gonna quit the stack here and do the shutdown process. So now all we have to do for the shutdown process, I got rid of the Stellarium part. Now I just have to park the scope. So this is where I go from here. I say park the scope, and before I do that, I'm gonna get rid of our focus system. I'm gonna disconnect it so that it gracefully shuts down. Shut it down. Then I'm gonna park the scope, and what that's gonna do is bring the scope to a predetermined position of safety, and it's a good mount position for us to be in at the end of the night. So here it goes. It's moving down, and you'll see it stop. Okay, there we go. Now it's looking kind of at the wall, but you still see stars through a tiny little bit of the telescope here, which is kind of interesting. And you'll notice now that the stars are moving. And I've said this before, that's because we're now watching the Earth rotate out from under the stars. Very cool. All right, so we can power down now, and I go to my observatory program that I wrote, and I can just use a simple command to power down. Telescope is not powered down. Pure power is off, and I can disconnect the scope. And once I disconnect, I can get out of this. So we're disconnected now. and I get out of this program, and I get out of the camera acquisition program, and we are all set. The only thing I have to do now is close the roof. Voila, sis boom ba. Here goes the roof. You can see the roof closing now. That's it. Now it's just a realm of spiders. Okay. So we're good. And we are done for the night. So thank you guys. I really enjoyed your company, and I look forward to doing this again with you very soon. So I hope you guys have a good night. And once again, when you go outside, keep looking up, because it's an amazing universe out there. We'll see you all later. Good night.